having Wi-Fi here? I think a very good question, because I do think I would need Wi-Fi. Okay. And the password is the venue1. Let me put this here where we can read it. The terminal. Oh, yeah, let me do that too. The venue. Yeah, if you go to the barcode, you will. Okay. Okay, but otherwise, let me move this down. Here we go. Okay, good morning, everyone. Thanks for coming. Let's just get started. If more people come, we'll go back to this page for an instant. So I'm going to talk about stream performance. How many people were at Venkat's talk that just passed? So there were a bunch of stream-related questions that if people had this event first, they would have answered it correctly for sure. Let's go into that. So I'll skip about me. So if you think about why are we using streams, and there's kind of the good reason to use streams is because if you look at the stream code, it tells you what's going on. Here in this case here, I have a stream of points, and that's the example that I'll be using. And these are just standard Java AWT point with an int x and an int y. I'll say the point is short if it actually fits in a short, meaning if the x and y are small. And so now then I'm going to apply a method that's, that computes the square of the length, and then I'm going to take the max, and that's what I'm doing. So you can see from the code what the intent here is. Whereas if you look at the equivalent loop, I mean, it's easy enough to read the loop, of course, but you do have to look at it a little bit carefully to see, does it really do the right thing? You notice that it goes through all of these things. It shouldn't, with max, shouldn't one only start at the first one or something like that? So when you look at a loop, you have to look at it with more scrutiny because there's more things that can go wrong in a loop. It's not as self-explanatory as the stream code. So the reason that many people write stream code is because of this advantage. Now, sometimes you can use parallelization, although you probably shouldn't in most cases. And so we'll talk about that a little bit. And so when streams first came out in 2014, everyone started writing stream code. There was a human urge to turn every loop into a stream because that was the cool new thing. And personally, sometime after 2014, I stopped doing that, and I kind of forgot all about streams. I would use them once in a while. But then about 2 years ago, I noticed that there was a flurry of articles and conference presentations and blog posts that talked up streams again. So like Venkat actually wrote a series of articles at dev.java at the Oracle site where he talked up streams and functional programming and used them to maybe a bit to excess. And of course, where do we find stream code? AI loves generating stream code. So I was just talking to François Martin, who is right now developing a set of skills that makes the AI move in the right direction and not to write terrible stream code. And he gave me some example of really scary looking code that the AI would produce automatically. So it is kind of a good idea to understand what the streams do more in depth. Also, you may have heard about that Java 25 added a new API to streams, the Gatherer API. We'll see it in action today. If you've never seen it before, don't worry about it. But I'm actually going to be using it as a showcase to think about performance. So the question is, of course, what about performance? And when you have a question about performance, there's no sense in guessing. You want to have some benchmarks. And so the usual way of doing benchmarking is with this tool called JMH. Here I'm linking to a blog article by François Martin, who happens to be here at this conference today. And I think at 1 p.m. he is giving a presentation about JMH. So if you're unsure about your benchmarking skills, you should definitely go and see that presentation. And so when you do these kind of benchmarks, you want to make sure that you first, outside the benchmark setup, and make any expensive setup, like if you have random numbers. If you were at my Valhalla talk yesterday, I had a nice example on how that can go wrong if you don't pay attention to it. And so let's look at an example here. So if you unzip this code here and throw it into IntelliJ, then you can read the code with me. Again, for those people who came late, let's just give everyone a minute to catch up with that. So there's a link to the source code here. And so if you like, go ahead and put it into your own IntelliJ. That way it's easier for you to maneuver around. But if you don't have a laptop or you don't have your IDE on it, don't worry about it. I'll put everything up there. Did anyone need another minute with this barcode, or can I go on? All right. As soon as I see that phone gone, I will move back. So we're here. So put this in this benchmarks, and the benchmark I'm running is filter map, I think. Yep. So let's have a quick look at filter map. So it has two benchmarks, one where I'm doing a computation with an array of points, and the other one where I do the same computation with a stream of points. And it's the computation that you've seen before, where I'm filtering with this is_short method. I'll show it to you in a second, where I'm then mapping to the square of the length. And it doesn't really, and it's an artificial thing. So let's see where I have my points class. It's here. So is_short just checks whether the x and y coordinates are short. So they're positive, and whether they're between. Oh no, they're not necessarily positive. Whether they're between the minus 32,000 and the plus 32,000. And then if they're short, then if I need to compute their length squared, I don't have to worry about overflow. I can just multiply the x and add the y and it won't overflow. Well, I guess it could overflow, right? But we're ignoring that. And that's what I'm doing here. All right, so if you run this benchmark, and I'm not running it because it takes like maybe 10 minutes or so to run it, since each time it needs to like warm up the VM a few times, and then it runs it, and it does a bunch of iterations so that it gets some decent averages. But if you spend the 10 minutes or so, then you're going to get this result here. And it's if we look through it, it says that if we run this with arrays, then it takes a certain amount of milliseconds per op. And if we run it with streams, it's pretty much the same. Right? The streams are teensy tiny amount slower, but it means we don't really have to worry about stream performance. And that's good, right? That means that if you see somewhere in your colleague's code that uses streams, you might feel that's A-okay. It's clearer, it's easier to read, and there's not a performance impact, so no need to bother the colleague to say, well, rewrite this as a loop. And so that's been what people have been thinking about for many years. So if you look at the old benchmarks, this Nikolai Parog did a benchmark. I'll give you a link that is about from 2014, and it says, don't worry about stream performance, is just fine. Then again, I ran across this master's thesis by some Danish student who says, actually that's not really the case. First of all, when you have small data sets, of course, the overhead of setting up the stream is large, and then it's going to be slower. And you might say, okay, but do I really care? I mean, with small data sets, there's not that much computation in the first place, so maybe I don't worry about it. The other thing that he observed, though, is when the pipelines get longer and more complicated, then performance can drop. And I'll show you an example of that that's fairly impressive in a minute. And it's just hard to predict when that happens. So in order to see that, we're going to now run the following experiment. So I'm going to be going into IntelliJ and run as an example the same demo that we've just seen here. This is in the filter map class. So it's in demos filter map. And so let's see what this thing does. It sets up this stream of points. We then filter. We're then running map. We're running map to int because it has an integer result. Then we call max. So here, we want to find the one with the largest length squared in this randomish collection of points. And so this code here, in order to do a little bit of micro benchmarking thing here, will actually run this computation multiple times. But for the demo, for the debugging demo, we're only going to be running it once. So if you want to follow along, it's important that when you go to settings, debugger stepping, how do I get settings? Debugger. Here it is. And let's see, it's called stepping. Oh no, I need to be here. Debugger. Does anyone see?
About advanced settings. This is the board on the left side.
stepping. Thank you. Thank you. Yes. See, I'm too close to the screen to see it. And there is a box that says always do smart set into. I think that's checked by default, but just make sure it's checked. And then there is a thing that's checked by default that says do not step into these classes. And for today, you want to uncheck that. Normally, you do not want to step into library code, but today I do want to step into the library code. All right, so then here in filter map, let me get out of this because I didn't make any change. In filter map, we're going to set a breakpoint onto filter. And now let's run this code here. Debug filter map. So it has reached the breakpoint. So now I'm going to step inside here. So, and it's going to now let me click on what I actually want to step inside to, because it's a big and complex thing. So I want to step into filter. And then here we see the code for filter. Has anyone seen this before? Okay, so a few people have. For the rest of you, welcome to level 2. So here we see the code for filter. And so when you look at filter, it goes right away, it says return, and it returns an object. Notice it doesn't do any filtering yet, right? It returns an object of some class, and that class has a method begin, and it has a method accept. And in the accept method, which is not yet called, it will be called much later, but when it does get called, then the accept method will call predicate.test. So the predicate is the thing that's passed into the filter, and if it passes, then it's going to use a downstream thing that it gets from somewhere and tell the downstream, hey, continue with the same element. The element will not be changed. That's how filter does. If, on the other hand, it didn't get passed, then the downstream will not see the element. So filter returns an object that has a method that eventually will get called and does that thing. Fine, we've learned that. So we're going to go back out. And we're going to look at what happens inside map in the same way. So I'm going to step inside map, and again, in this way. Now here we're seeing what map does, or map to int, and it looks very much the same thing. If you look at the structure of the code, it also returns an object of some class that we don't have time to look at in detail, but it's an object that has a method called accept, and that accept method will unconditionally call downstream.accept, namely with the value that is obtained from the stream value u after it's been treated with this map. All right, so that's how what these things do. Let's get back out. And let's go inside max. Okay, now, sorry, I should have set a breakpoint there. I'm going to start this one more time. Okay, I guess now I can go here. All right, so I want to go to max. Run it here. Okay, here we go in max. We go inside. And now it runs, you can see max will then call reduce with an operation and so on. And I could now debug, and it goes several layers deep, and I don't actually want to do that. So instead, let me actually, before I run ahead of myself, let me have a picture of what has just happened before at this point. So there is a splitterator. We'll talk about that in a minute. What it does, it generates a sequence of the stream elements, Then they get fed through a filter. So this is an object that has some method that eventually will do the filtering. Then it gets fed to an object that does the mapping. And now the next operation is different. It's what is called a terminal operation, and that's where the action will start. So, and so if you set a breakpoint in abstract pipeline.copyInto, so how the heck are we going to do this? If you go to external libraries and you go to Java util stream and then abstract pipeline, then search for the copyInto method. It is in line 566. And now I'm just going to run the code, and it's going to get into copyInto. And I want to look at this, this little piece of code here to see what it does. It's now going to test what's called a short circuit flag. We'll talk about that later. And it's going to go inside here, and it's going to call a method called forEachRemaining. So now it's good to know a little bit about what a split iterator does. A split iterator is just like an iterator, you know, a good old iterator where you have has, next, and next. But it has a couple of other things. It has a forEachRemaining that just calls next, has next and next in a loop. And the rationale is that for many data structures, like if it's based on an array, it is better for the JIT to see the loop in one place rather than having multiple method calls. And so that's why they put it in there. The other thing that a split iterator has that's important for parallel work is the split iterator can be asked to do half of the work on one half of the collection and return another split iterator that can do the other half of the work on the rest. So if your data structure is an array, you can imagine that the split iterator has an easy life. It just cuts the array in half, gives a new split iterator for the rest, and then works on the first half. If, on the other hand, it's a linked list, then it would have a harder time, or if it's a binary tree, you know, it might have a harder time splitting it in two. Well, on a binary tree, maybe not, but on a linked list. So that's what a split iterator does. All right, so remember forEachRemaining, and that's good. forEachRemaining has been done so that the JIT can easily do this. All right, so if we step inside forEachRemaining, so let me do that here real quick. Then we are here. So notice how forEachRemaining is written. This is not how I normally write a loop. This loop was written by someone who intimately knows what's good for the JIT. So the just-in-time compiler, when seeing this loop, will be slightly better at turning that into a loop in assembly than if it had been written in a different way. And notice what the loop does is it calls accept. Let's go to there and then trace into accept. So here we are in accept, and this now should look eerily familiar, right? This is the filter. We've seen it before, and now the filter code gets called. Now this was something that Venkat demonstrated earlier today where he had a stream pipeline, and the mapping operation referred to some array element, and then before calling the terminal operation, he changed the array element, and about a third of the people was surprised that the change was visible in the map. That's, of course, because the map was only executed after the terminal operation got started, and that's just the way it is. That's the laziness of the collections. So if this test passes, let's see, there's a chance that it does pass. In this case, it didn't pass. So I'm going to let it run a little bit longer. I set a breakpoint in the downstream thing here, because eventually some of them will pass. Now I'm going to go in there one more time. This code should also look eerily familiar. Now after we have a situation where the filter passed and the downstream mapper gets executed. So that gives you an idea on what streams actually do. They first set up this pipeline, and then eventually they iterate through it. All right. So this is just in words what we just did. So now that you've seen it, now how much more inefficient is this than writing the loop? You've seen the code for the loop. Yeah, that's the for loop, and it immediately called the if, and then called the method of the filter, and then it did the transformation and did the max. Here, it's all much more complicated, right? It first sets up this chain of operational mini classes, and then when the elements came in, then an except was called, another except was called, and eventually it gets passed on to the thing that handles the max, and when that thing is done in the very end, then the max pops out. So it looks like it should be a lot less efficient. On the other hand, the benchmark didn't show that, right? The benchmark showed it was pretty much the same. And so it's a good question why. And to answer a question like that, one really wants to look at the JIT code. And so in order to do that, you want to take a recording of all of the JIT operations. So when a Java program runs, it first starts out interpreting your code. And as soon as it finds that some methods are called frequently, or that some loops are called frequently, then it turns on the just-in-time compiler and turns the bytecodes into machine code. And it does that in stages. There's multiple stages. The stage that you want to reach to really have the optimum quality of code is called C2. And so we want to see that C2 gets into action, and it will do that soon enough. This loop gets executed, well, it depends on how often I want it. In this case, yeah, I've executed the loop 300,000 times. That's enough for C2 to kick in and do its thing completely. And then one can look at the assembly code. And so let me actually do that. Did I load JIT-watch? Nope. All right, so here's JIT-watch. I have hopefully this log prepared. Yep. So I have to click on start. And why do I not see my own code? That I don't know. Okay, maybe I'm just going to have to rerun it. Yeah. I'm just going to boldly rerun it so you can see what a JIT-watch run looks like. And so what you see flashing by is every time that the JIT kicks in and optimizes out something else, when it recompiles something, it sends these messages that are somewhat difficult to read, and the point of this JIT-watch tool is to gather them all up and make them easier to consume. It has now produced a file, and the file is called jitwatch.log. So, oh yes, I see. So let's just run it one more time. Here. So run jitwatch. I opened the log file. Oh, I see what I might have done wrong. The user interface is not stellar. I have to click on. And now I'm still perturbed I didn't find my classes, so I might have to look at the config. Config's fine. So let's see if I can fake this. If not, I'm going to have to. All right. I'm going to look at. No. Maybe I didn't recompile it. Let me double check that I recompile it. It was in demos. Maybe if it is. For some reason, it's not finding the source of my. Let me try it this way too. No, I didn't mean Java C. That's what the problem was. Filter map.log. Okay. Sorry about that. Source main Java. Okay. Class locations. No, I don't. That folder. So I have to set up where it finds my classes. Let's hope I did it right now. Okay, that's too bad. I don't know what's. Say again. Oh, okay. Oh, yeah, thank you. Okay, let's try that. Well, that's a shame. Okay. What's that? No, I'm looking for. I'm being stupid. Thank you. Yep, here we are. Okay, so here we have the points, but it's still weird. Filter map. Yes. Thank you. I'm too close to the screen. So here we see the loop. So I want to go into the largest distance, and when I go inside here into the max, oh, why is the assembly not found? Oh, I know. It's because I skipped an essential step. I have to do this one more time. You have to also make it so that JITWatch can see the disassembly. So I have to set the library path so that it can find it. So now we do it one more time. Now that we know how to do it, it was filtermap.log. Okay, I think now that should be fine. Now that you've shown me how to how to find this thing. Okay. Yeah. Okay. And then we are in largest distance. And now it finds the assembly. So when this method here was max, and you can see that max was inlined. That means that the JIT has put in the code for max, and in fact, if we carefully look through the assembly, let me turn off the source, which we don't need. Real programmers don't look at the raw Java source. And if we were to look through the entire code here, when one can find that it has unrolled the code for doing this, this going through the pipeline. And in fact, let's see if I follow this. And I'm not going to do this now in the interest of time. If you trace through where the for each remaining was, you will see that the loop that was in the for each remaining is now expressed in assembly instructions. It takes a few minutes to find one's way around the assembly instructions, and so it's not something for the faint of heart. But trust me, at this point, what the JIT has done, it has taken what is several call levels deep that you've seen when I debugged through them, and turned them into a linear stream of assembly instructions. And that's the best you can hope for. At this point, the JIT produces code that is pretty much the same as if you had handwritten the loop. So it is possible, when everything works fine, for the JIT to be very competitive with a handwritten loop. And so there's no need to automatically take every stream and turn it back into a loop. But now we're going to make a tiny change. And so I'm going to take the same pipeline that I had before, and I'm going to add a limit to it. And now if one were to trace it again, and if you remember where I was in the copy into, and again, in the interest of time, I'm not going to do that, then one will notice that instead of going into the for each remaining, it'll look at some internal characteristics, we'll see that in a minute, and then it says, I'm not going to call for each remaining. And of course, the reason it's not going to call for each remaining is for each remaining goes through the entire split array contents and runs it all through this one except thing. And with the limit, you can't do that, right? You have to check whether you have reached the limit already. So there has to be something that says, no, should I stop doing this? And it's going to use a different pathway. And in that pathway, it's going to go through the following code. It's going to have a different loop where it checks whether the sink, meaning the stuff that goes down further down, which in this case here is from the map to the limit, whether it wants to cancel the computation. And if that's the case, it's going to cancel. And also if the iterator, then instead of calling for each remaining, it's going to call try advance, which is this pretty much the same thing as calling next on a regular iterator. And so it's a different loop. That's what I want to point out. And yeah, it does that. And so when the limit is reached, the cancellation happens. So when you make a change in your stream pipeline, so let me show you again the code in Java. This is the filter map limit. It looks exactly like the code that you've seen before, except that I've tossed in a limit. And that changes the internal computation. And you say, so what? Of course it changes the internal computation. It has to now take the limit into account. But when you look at performance, this is a 50% performance hit. Did you know that? That if you put a limit into a loop, that it drops performance like that? Somehow, Nikolai Parlog, 12 years ago, when he did his benchmarks, managed to not hit upon this. And so, thanks to that grad student in Denmark, who had a more systematic analysis through these things. So this is something that you could easily imagine yourself doing. And at this point, it is probably worth recoding this as a loop if it is performance critical. If it's not performance critical, then still go for legibility. But that's why I know people who say that whenever they go into a consulting situation and the code is kind of slow, they rewrite all the streams into loops. Because this effect is real. It's not something that just doesn't happen. And so, I've done a flame graph. I'm showing you here how you can do that at home. And so when you have to, oops, why don't I see my flame graph? Maybe because the link is wrong. be with me for just a second here. jcon. No, I'll just show it to you in the browser here, as I have it here. Filter max limit. So we're going to be looking at both of them, yes. With array, CPU forward. Here's how the flame graph looks like with arrays. And so the flame graph shows where the code spends time. So this is the method that we're debugging, or that we're profiling. So the computation of is short takes a bunch of time. Okay, it has to check for whether the point is within range, and it does that for a bunch of points. Now, when we look at the flame graph with the streams, CPU forward, you notice that the flame graph out of a sudden looks completely different. So you can here see that it's spending a bunch of times into some in some internals. And look how much time it spends here in things like cancellation requested. So it spends a lot of time in this cancellation machinery that you wouldn't think is a big deal. And the reason for that is ultimately that this code, the one for cancellation requested, can't be inlined. When you go through it with JITwatch, you will see that it's not inlined. And there's a reason it can't be inlined, because when you look at the source code for cancellation requested, which I'm sure none of us has ever done before, it's polymorphic. The compiler cannot, the JIT cannot tell that what the nature of the object is. And it can only inline a method if it's a single method. But if it could be overloaded, if you have a reference to something that could be an object of one type or of some other type, then it could speculatively inline it maybe, but it won't in this case, because it does not have enough runtime information to do that. And so that's a problem. And so you have a minute change in strategy, and it has an impact on performance. So it does mean that if you, in your code, if you use streams that go through large data sets, it might, and if you suspect there's some performance issue, it is worth your time to start benchmarking them, because there's no simple rule that says when they're fast and then when they're not. And of course, things do get much worse with parallel streams. So I think here we all know about parallel streams. So I'm showing you here, again, the happy day scenario where I'm running this computation over here, same computation that we've seen multiple times. When I run it with a serial stream versus with a parallel stream, you see this is the happy day case where this parallelizes very nicely, because the filtering and the mapping can easily done in parallel. The accumulation, the max, is also easily parallelizable, because it can find the max for each subset, and then in the very last step take the maxes of all of them. And what is the factor of parallelization? It is the number of cores that I have. So my laptop happens to have 14 cores, and so I get pretty much exactly the speed up that I want. These kinds of benchmarks were well documented 14 years ago when people first did streams. And so the answer is, if you have a computationally heavy task, go forth and run parallel. That was considered a real selling point for streams. And it is if the task that you have is heavily computational. Now, in business logic, we don't often have that. And so in 99% of the case, if you're writing a Spring Boot application and someone puts parallel streams in there, the answer has got to be to take it out. Because what people instead do is they put blocking calls into parallel streams, and that really, you know why that doesn't work. All right, so now we're going to make a small change to this computation. And so I'm going to I'm going to apply the map, then the filter, and then I'm going to toss in a limit. And how do you think performance is going to go? So we had a limit before, and it had a performance penalty of 50%. Is it going to be the same, more or less? You would think the same, right? Okay. We're now in an unhappy situation where parallel is slower than serial. Okay. So that is not good. And it's not clear why, because this is computationally heavy, right? It should be a good use case. And so the naive idea that one has is, you kind of say, okay, it's going to, in parallel, going to compute a lot of these values. And with the filtering, okay, I mean, it is a bit of a problem that probably the filter is going to kick in pretty early, and some of these values here, they're never going to make it through the filter, so that was maybe a bit of a waste, but hey, we had the core sitting there. But that is not how it works. So you have to know that a parallel pipeline will never speculatively apply a map operation. So it will simply not do what many people intuitively think. It will not compute these and throw them away later. And so in this case, the opportunities for parallelism are not great, right? Because it first has to compute all of these and then see whether the filter and the limit made it so that they all need to be taken. And only then will it start calling the map on the next branch. So it will not speculatively call map, because the idea is that map is supposed to be something that's super expensive. Every call to map is supposed to mine a Bitcoin or some such thing. And so you look at this and you have some idea of what the workload is in mind. But the parallel streams, they had to implement it somehow. And so the decision they made is that when someone calls a map on a parallel stream, surely that was super expensive, and I'm not going to speculate and call it just for the heck of it, even though performance would be much better, right? You might burn some computation in some otherwise unused cores, and your final result would be better, but that's not how parallel streams work. All right. So with that, quick intro into gatherers. So gatherers are an API to produce intermediate operations. A bunch of gatherers are given to us, and I think if I just show the first ones, you'll see the beauty of what a gatherer can do. Sometimes what you want is you have a stream of things, and you want to batch them together. So here I have a stream of integers, and I say I want to batch them together. I want to have groups of 4, except for the last one where I didn't have 4. Or maybe you want to have sliding windows like you have here. So what you need is an operation that takes a stream and produces a stream. Up till Java 25, there was no easy way for you to write such a thing. And so now they have this gather API that makes it. These two gatherers, the window fixed and window sliding, they come with the API. There's a couple of others. There's scan and fold. They're not common, so I'm not going to dwell on them. There's a pretty nifty gatherer that will map concurrently on virtual threads. So here I say, I want to have 60 virtual threads, and I want to run this blocking operation on it. And this is perfectly safe, unlike parallel streams where it would not be safe. So you can write your own gatherers. So I'm writing a simple example of one here. And so here, oftentimes it happens that you have a stream of values, and you would like to know the position of each of the values. Well, how are you going to do that with streams prior to 2025? You could maybe have a global variable, and you increment that in the Lambda, and then Venkat would not be happy with you, right? So there was no great way of doing it. But now one can easily write a gatherer, and here you see how you write one like that. So this is a stateful operation. There's an intermediate state, namely the index, which needs to be updated with each scene element. And so here's how you do it. So this is the constructor for the state, which in this case just holds the index. And then I have to define, I say I want to make a gatherer, and I'll talk about sequential in a minute. And when the gatherer sees a new element, then it's supposed to execute the following lambda. This is the new element, this is the current state, and the downstream is where we're going to push the result to. And we're going to be pushing the index, conveniently incremented here, don't code like that at home, and the element. What's map.entry? It is the poor man's pair. There is no pair class in the Java API, except of course there is. Map.entry makes a pair with a key and a value. And so, why make a new record pair if map.entry is just sitting there? So just here to keep the slide short. So here I'm making a pair with the index and the element, and what comes out of it is a new stream of pairs of long and t out of the old stream that just had t's in there. So that's how you implement a gatherer. And so it's that part is easy. What about off-sequential? There's two kinds of gatherers. There's gatherers that work with parallel streams, and there's gatherers that will only work with sequential streams that will then force the stream to be sequential. In this case here, this thing cannot work with parallel streams, because if the split iterator takes a thing and chops it off into two, there's no way in the API, unfortunately, even though in theory it should be able to figure out the size, there's no way to get that size and feed it into the new state. So this gatherer is limited to sequential streams, and that's why it's called off-sequential in the API. If I have a different gatherer that does work with parallel streams, then I can say gatherer.off, and then it creates a gatherer with a different characteristic. This one here will force the stream pipeline into sequential, even if you declare it as parallel original. So that's the one thing. And that one I thought was easy enough to understand. The thing that I didn't understand when I learned about this API is the off-greedy thing. And so what does it mean for a gatherer to be greedy? And so if you have a child, maybe 6 or 7 years old, some children at dinner, they are greedy. They will eat everything. Some children at dinner, they are picky. And, they maybe will want to eat things, but oftentimes they refuse. So that's the distinction that is here. The question is whether this gatherer is willing to take all elements and absorb them, or whether at some point it says, nope. So if you wrote your own filter, then that would be greedy because it's willing to look at all of the elements. But if you wrote your own limit-like operation, then limit is picky because at some point says, I don't want any more. This one here is greedy because it's willing to look at all of the elements. And so when you write your own gather, you can explain this. So I was really baffled when I first saw this API and says, how should I tell the readers of my books when should they use greedy and when they shouldn't use greedy? And why does greedy have the weird name instead of the nice name and all of that? And so you now know more than I did at the time, namely that when the gatherer isn't greedy, then the routing can't go through for each remaining. We've seen this with the limit case before. And so are there any other benefits? So I asked in the core API mailing list, and I got the following answer, that it's from the mailing list mafia. You get an answer that you can't understand. And so it says, greedy allows for less signal tracking, which in aggregate over separate operation can have a noticeable advantage. Keep in mind that this is primarily around the sequential performance, which in Victor's experience was more common than parallel streams. Now, of course, Victor is totally right. There are cases, and you now know how to construct them, where you can directly observe greediness on serial by benchmarking it. But I was also surprised by this parallel thing. Of course, Victor is again right that in most of the time in user code, you don't use parallel. But when I first saw that, I completely misread it and said, greedy is important for sequential, and it's not important for parallel. And so then a bunch of us got together at some unconference, and so Sven Waltman presented some code where he experimented with these gatherers. And in the end, I couldn't understand what he was doing, and I made all of the different combinations where I had streams that were, were parallel or serial, and then I applied a gatherer that was parallelizable and greedy and picky and everything like that. And it turns out that it has a super big impact on performance, which came as a bit of a surprise for all of us. And that in the end, the problem is similar to what we've already seen in the simpler cases, that when you have a parallel operation and then later in the pipeline you have a picky when you have a picky gatherer, then it limits the opportunity for parallelism. That all of these parallel computations, they sit behind a barrier, and I could be having another, really a 3-hour workshop on analyzing exactly how the parallel streams do this. So there is a complex way of how the parallel computations are organized so that nothing happens before they're necessary. And we don't have to know the implementation as long as you understand the concept that in a parallel computation, nothing will be done until it's known that the value is needed. And so it's that thing that means that if you write your own gatherer, and if it is greedy, you should really, really declare it as greedy, because otherwise it has bad performance in these parallel pipelines. Now you would think that then that is now has become common knowledge on the mailing list for this topic. 2 weeks later, someone gave a code for a gatherer that was greedy, like it could be greedy, but it was not declared as greedy, and so therefore it would have bad performance. So it is tricky to do these kind of performance things, and so it's good to get some more intuition about it. And so that's how I want to finish now, because I know it's just me standing between you and lunch. So so when you see in your place of work that people use streams, that can be good. Streams can make your code easier to read, and if performance is not an issue, easier to read is good. On the other hand, you should never assume. I mean, the streams cannot generally compete with a hand-coded loop, except of course if the computation really can parallelize. I mean, you couldn't easily write that loop yourself. It would be more work, but that never happens in a general business situation. So it's interesting to know about parallel streams, but it is true that they're not super common. And so there's only so much the JIT can do. The JIT is pretty amazing in the best case. It is amazing that it can unroll a deeply nested set of these instructions, and you can actually, with enough time and patience, you can watch it do that. But as soon as the pipeline gets more complex, the JIT is limited. What this Danish student also did, he had some cases where the pipeline just got long enough that it ran against the inlining threshold. If you have too many nested calls, the JIT, like more than 10 nested calls, the JIT will just, it's hard-coded to throw up there. You can change that with the command line option, but do you really want to run your code with an option in production that says, I want to have an inline depth of 15? I mean, I wouldn't go there. Right. So yeah, parallelization can work, but there are many ways in which it doesn't work. So I would say every time that you see parallel, it's probably a code smell. You want to look at it. And benchmark, benchmark, benchmarks. So anytime that you run into this, it is well worth doing the profiling, and it is worth for someone on your team to have some expertise when you do this. So work on your mental model on how these things work, and have the tools available to do that. So that's the message of the deep dive. I hope you found it somewhat useful, and if not, there's always lunch. Thank you. Any questions? Yeah.
So is the difference in performance from the streams to the race when the method is hot? Is the hotness the issue?
Yeah, I think. Okay, so your question is whether the difference in performance comes from the hotness, and I don't think it does. I mean, the hotness was the same in all the examples that we had. We ran the same computation, whatever, 10 million, 100 million times, and so that's the hotness comes from how often the iteration works.
Sorry, I meant that if we take like a snapshot of it when it's already hot, would the difference be more equal?
So the question is, does it matter when we take the snapshot? And so that's why it's important to use like a micro benchmarking harness, because it will first warm up the thing so that what you measure is after the hotness stage has reached. Because otherwise, your results are going to be murkier. So you definitely, and JMH makes that kind of painless. So go to Francois' talk and see how to do JMH if that's not something you have done a lot. Yeah, other questions?
Which other operations like limit are breaking the optimization of the data?
Yes, so I mean, the problem with limit was the way that it broke the optimization was obscure, right? That it's not that it intrinsically should necessarily be bad, but that the implementation of it was not so great. And so I talked to Brian Goetz about that. And so, of course, they're aware of these things, and they say, yeah, maybe it would be worth, re-evaluating the implementations and see how people are actually using it today. And so eventually, there's no reason why one couldn't do better with this. But the way that the library exists today, yeah, in the JDK that you are using, is there's no great way to reason about it other than measure and analyze. So now you've learned that that limit by itself is bad because it turns it into this bad pathway, and you can follow through the slides in slow motion to see exactly where that hits. But it's not a great actionable knowledge. Right, so I wish I could give you like 5 recipes of what to stay away from, or some skill for your coding agent or what not to do. But it's not that simple. Yes, so unfortunately, in benchmarking, profiling, or even going down and understanding a bit of how the implementation works is worthwhile. And certainly, benchmarking is really a good idea if you suspect, if you have big data sets that you actually work on. If you have like Venkat's example where you had 7 people and you run map and filter, don't worry about it. All right, thank you very much. See you around.
it's rainy. I mean, I don't know. Yeah, I've seen storm, but I'm not sure if. I hope there won't be. It's orange. Yeah, the weather. They on the weather forecast they said orange. Okay. Yeah. No, not windy. Okay. But I think it. I mean, I do prefer it's raining that versus being in hot temperature, and I'm more a winter person rather than a summer person, to be honest. Yeah, I'm based in Munich, and Munich it's rainy too. I mean, oh, warning for thunderstorm. Yeah. Hello, welcome. If you need the Wi-Fi, it's on the wall, right here, right here. The Wi-Fi is right here. I don't know. I mean, probably switch something. Whatever. Do you think? Hello. made a minor adjustment. Thanks to the guys in the back, we can share that video. That's gonna be cool. What time is it? Oh, it's almost. In any case, the Wi-Fi is on the wall. If you're not connected, just behind the wall, so you can get it. The venue and the password won't be leaked on the internet. So. Let's wait 1 or more 2 minutes, and then we start. We have 2 hours, if I'm not wrong. Yeah, cool. So I think it's 1 p.m. If people join, they are more than welcome, but I think we're gonna start. In the back, ready? All good? Perfect. Thank you very much for joining this workshop. It's a, come on. Oh, come on. You are more than welcome. The Wi-Fi is on the wall, and have a seat. It's going to be a great workshop, a great time all together. So thank you very much for attending this workshop, even more as it is a rainy day in Sofia. So that's going to be cool, but we're going to have some fun all together. How many of you know what is a tabletop role-playing game? I know 1, 2, 3, 4. Okay, but not all of the room, a few people in the room. So let me state a common ground and share with you what is a tabletop role-playing game before we go into the details and how to practice in the workshop. So when you play a tabletop role-playing game, you do actions. And these actions are made through dices. You have to roll the dice in order to perform your action. And if you are lucky enough, then the dices will be with you and you will succeed your action. It will depend on certain parameters and so the action that you are doing, and the character that you are playing is the one that you have created. Can be a warrior, can be a druid, can be a dragonborn, a monk, a sorcerer, and so on and so forth. My nickname is The Witcherish, and that's why I try to mimic The Witcher. But let's see what is a party when we play a tabletop role-playing game. A video is worth 1,000 words.
Play D&D? Sure. All right, you've got a bow strapped to your back, a sword and a dagger, right? So you're walking through the woods. It's dark, it's at night. Almost no moonlight is coming through. You hear a crack off in the distance. Something large stepped on the branch. What would you do?
First thing, how far away is the crack?
Give me a perception check. So you roll dice and we'd see how perceptive you are. Let's say you roll a 13, okay? And you're pretty perceptive, so you have a +3.
History check.
So this is what happens when we play tabletop role-playing game. So, and this is what we're gonna build all together. All together, we're gonna use Spring AI and build a multi-agent role-playing game application. So we're gonna go step by step, and it's gonna be fun. I'm Arno. I'm a developer advocate at Amazon Web Services, but for the rest of the workshop, you can call me the Witcher-ish, because I don't look like Geralt, even I would love to. So that's why, and I'll let you pick your favorite character name. So you can be whatever you want. You can be Ragnar, you can be Thorin, Oakenshield. This is your time, okay? So let me share some common concepts that we're gonna use in order to implement this multi-agent role-playing game using Spring AI. So a tabletop role-playing game, for the one on the live stream, it's a collaborative storytelling game where players create unique characters with skills, background, and personalities. Then you role-play your decision using dices, and we've seen dices, like dices can be D4, D6, D10, D20, or D100. So there are different kind of dices when you're playing such game. But when you play a tabletop role-playing game, I mean, personally, I do prefer being a character in the story. Being a game master, crafting a story, narrating it, adapting the story on the flow, based on welcome, have a seat, based on the experience. For example, if your players decide to befriend with the dragon instead of fighting it, then you have to adapt your story on the flow and to make sure that you can pursue the adventure with the players of your party. So that's why being a game master can be hard. It requires a lot of skills, creative skills, calculation. You have to know the rules of the game, and so on and so forth. And you know why? AI is really great at storytelling. So that's why, in fact, our multi-agent role-playing game is going to be an AI game master that is going to interact with several agents. What's an agent? Well, before talking about agent, I'm sure you know LLM. You heard about yesterday if you were attending jPrime yesterday. LLM like ChatGPT, Mistral AI, and so on are trained on a certain data set, a certain knowledge, but they cannot extend to the real world. They cannot interact with your API, with the databases, your file system, and so on and so forth. So this is what truly differentiates a simple LLM versus an agent. An agent is going to use an LLM in order to resonate and iterate, but also will have access to tools. And what a better tool than a hammer in a tabletop role-playing game. But not every tools look like a hammer. So a tool can be an API, it could be an existing function in your code base, in Java, in Python, whatsoever. It could be an external service that you are reaching. Oh, hi, mosquito. And the agent is going to use it based on the description of the different tools to fulfill the request. Let's say you want to create your character, you want to create, I don't know, foreign Oakenshield, and you need to provide some skills and some behaviors, and you're going to provide to your character agent all the instructions and tools to let you create a character. But these tools can work locally, that's great, but in a real-world environment, we need to deploy it onto production. And then this is where MCP, or Model Context Protocol, comes into the picture. MCP, a protocol released by Anthropic, allows the communication between agent and tools. It can be any LLM provider. It could be provider from Anthropic, from Mistral, from Amazon. MCP standardizes the way agents communicate with tools in the same way. You can think about HTTP, but for AI agent. So that's really, really key. It's going to be really key in our architecture today, if we want to roll the dice. And also, we have MCP for tools, but we are not going to build one big agent. If we do so, it probably is going to fail. So instead of building one monolithic agent, what if we could build specialized agents in order to collaborate all together and to connect these agents all together? Well, this is the purpose of A2A, agent to agent, standardize how agents communicate and collaborate among each other. So thanks to agent, each agent is going to expose its own capabilities through an agent card, and this card is just a simple JSON file, and then they're going to all discuss and interact in order to achieve the result. So enough of concept. This is what we're going to build. Here you are. This is you. You're going to build your first AI game master. And then once your AI game master is going to be alive, you're going to provide it some built-in tools to your game master. I don't know, like fetching the web for looking for specific information. Then you're going to create your own custom tools. So you're going to create a roll dice tool in order to roll the dice. And once you created your tool, your custom tool, probably you want to package it as an MCP server and to expose it to everyone in the room. So you're going to create your own MCP server with one tool. And then, because we said we want a multi-agent tabletop role-playing game. So if we want to provide this multi-agentic system, then we need other agent. And so you're going to create a rules agent, which is familiar with the rules of the tabletop role-playing game, with a knowledge base that you're going to create, and it's going to be associated to it. And then if you want to create your favorite character, then you're going to create also a character agent. And this character agent has access to character database to store the ability and statistics and inventory items of your character in your journey. Great. Are you ready to implement this architecture altogether? Cool. So to do it, we're going to use Spring AI for sure, and we're going to use Spring AI community library, which provides some elements and support, especially for the MCP and A2A protocols. So it's going to be really useful. And in order to provide the brain to our agent, we're going to use Amazon Bedrock, which is a service where we can consume any LLM via an API. There is a Converse API where we can converse with every LLM. So in the workshop, you're going to use probably Claude, IQ most of the time, but you can switch to any other LLM if you want to. Okay. To join the workshop, first thing, to go to that specific URL, welcome, have a seat. And by the way, if you want, there are stickers at the front, so feel free to pick at any time stickers and have some drink or whatsoever. So join this specific s12d.com/jprime-aws. I think there is enough account for people in the room. If you're on the live stream, you can definitely join by using this URL. I hope there will be enough accounts. I'm gonna do the same as you. Everyone copied the URL. Everyone is fine with the URL. Yeah. Okay. Took pictures, that's fine. Welcome. Have a seat. I'm going to do exactly the same, just to go through the first steps with you, and then you can be on your own. At some point, we're going to do checkpoints. So I'm going to, we have 5 chapters to go through. Let me share. So, you know what? Let me share something. So join the URL, and while you are joining the URL, here's what we can expect. At the end of the workshop, this is what we can expect. You have an UI that is already developed and deployed, so it's running locally. You will have to use it during the chapter 5, but this UI can let you play with your multi-agent game master. And how? Well, you're going to have several agents that you're going to make it up and running. So a rules agent, like I said, the character agent that's going to be up and running, your MCP server to roll the dice, and also the game master itself, game master orchestrator. You see these different applications are running, so all our agents are running, plus the MCP server. And if you implemented it with success, then you can create your favorite character, like, I don't know, Sauron, for example. What's Sauron gender? I'll let you choose. I'll let you. Non-binary, okay. Which race? Elf? Ah, I like it. Which class? Sorcerer or Warlock? Warlock, okay. And so this is the endpoint of your AI Game Master, and you can click on Begin the Adventure. And if you go back to the agents, you can see that the Game Master is going to communicate with the character agent in order to create Sauron. So Sauron is coming to life. And it's probably roll the dice or not in order to calculate the ability of Sauron. But Sauron has been saved into the character database And so the agent can use it. We can see the statistics of our new player in the game. And if we go back, then you can start the adventure and say, welcome, Sauron, to the realms beyond mortal ken. You emerge from a twist-torn gateway into the ancient forest. Run! And then the AI game master will continue, iterate with the specialized agent, and summarize the response and send you Sauron bolt, you elven legs pump beneath you as you crash through the underbrush. Okay, so at the end of the workshop, this is what you're gonna get. You're gonna get the UI, which is already available, but thanks to the agent that you're gonna develop, you're gonna play with it, and you will be able to play with it. Cool. So if you join that specific URL, for those that just joined, now you should be, I don't know if you were already connected or not. I'm already connected to the workshop. Normally you should land on this page if you're authenticated. If that's not, let me re-authenticate. Up. If I'm taking that link. So the link that I shared, you should be on this page, probably. So you can pick email one-time password, put an email that you're gonna use for the workshop. It's not saved after the workshop. It's just to make sure that you get the same AWS account when playing the workshop. So click on email one-time password, provide one of your email. If you are using AWS, you probably also have a builder ID. You can use it, or I will use an Amazon employee in my case. You have the terms and conditions to accept. It just says that you are above a certain age, depending on your country, and the accounts provided by AWS are intended for the workshop, and that's it. So you just agree with the terms and conditions, and you can join the event. Once you join the event, so you should reach that page that I was sharing just before. If you have some permission issue on your laptop, if you are dealing with proxy and so on and so forth, I got you. There is a code server that you can use over here. It has no auto-completion, but you can add plugins, and it's a code server where the code from the workshop has been already cloned and is available. So feel free to use that one. If you do prefer to use your machine, use your machine. We love when it works on our machine as developers. So feel free to pick one of the above. So there is a code server that you can use. And the first thing is to start our journey altogether with the chapter 0. And in the chapter 0, you have a strong decision to make. You have to choose your path. Which path would you like to experiment? So this workshop, I've initially created this workshop using JBang. JBang is a way to script your Java classes and your Java program. So you can just run JBang, your Java class, and it's going to execute the program. Or if you do prefer to do with IntelliJ, there is an IntelliJ path, and you can definitively use it. Just make sure that if you pick one path or the other, to stick to this specific path. If you pick JBang, stick with JBang. If you pick IntelliJ, stick with IntelliJ. That's it. Apart from that, you should be good. The first thing is to clone the repo. So the Git repo, to clone it on your local machine if you are not using the code server. And then you will see the 5 chapters once you clone the repo. I'll zoom in a little bit because it's, I think, very small. You should see the 5 chapters. So chapter without the dash maven, it's the JBang, and chapter dash maven, it's the IntelliJ path, where you have the same structure that we are used to. And chapter 1, you can see. The only difference between JBang and IntelliJ is that in JBang, JBang is resolving our dependencies by using this command like / the Java version. So we are using Java 25, the repositories that we are targeting, and our dependencies, plus the runtime option if we want to provide the runtime options. That's the only difference. Using the IntelliJ path, everything is in our pom.xml file over here. So clone the repo. That's the only plumbery that we are doing. Then you are good to implement and develop on your own. Clone the repo, and once you clone the repo, let me know when everyone is good with the repo. Good. Clone, 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 clone. Okay. So next steps is to get an API key from Amazon Bedrock, because we want to do the inference using Amazon Bedrock as a backend. And if you click on it, it won't do anything. So on the left, you have Open AWS Console. If you click on Open AWS Console, it's going to open a new tab. And you should reach that console. And if you type in the search bar Amazon Bedrock, or just Bedrock, I think it's enough. Yeah. If you type Bedrock in the search bar, and click on it, click on the name, you reach the Amazon Bedrock console, and on the left, what's interesting is the API key over here. And if we go to API key, we can create short-term or long-term API key, but short-terms are valid for the next 12 hours, so it should be more than enough. You can create a long-term if you want, but if you click on generate short-term API keys, you can get it from Mac/Linux or Windows, based on your operating systems. You can copy it. You can generate it as many times as you want, no worries. And these API keys will be, for example, in the code server. If I open the terminal from the code server, it's just, okay, to pass the API key. So when I will run the Java class, then the API call to the LLM will work. It will have credentials to succeed if I want to run the dungeon master simple.java class, for example. Of course, that would be too easy. Now it's your turn. Oh, there is a solution, because I tested it before. So now it's your turn. You have to-dos to implement. Everyone is good with the API key? You copied it, so saved it somewhere in the notepad.txt. You're good. Okay. If you got the API key, now it's your turn. So jBang, I'll let you read the instruction on that one, but if you can start with chapter 1, and with chapter 1, then your first quest, so we have 5 chapters to go through. The first quest is to create an AI game master and to bring it to life by summoning it. And I heard this morning in the session that I attended that it's really, really important to read the documentation. So I'm just going to say we have Spring AI documentation that is really, really helpful if we want to create our first agent and bring it to life. Yep. You're good? You clone the repo? Oh, you're going to the jBang path? Yeah, you can go. You can definitely go. If you are using your own machine, you have to install it. Otherwise, in the code server that I'm providing, it's also available. Yeah, I think it's. You're good with the API key? It's chapter 1? Okay, you're doing with jBang yourself? Cool. You're good? I think we met, or I think Agent Camp? No, no. Okay, but I'm sure we met. You're good? You got the API key? Perfect. Yeah. So you can go to the. You can in fact open one chapter per one chapter, and it's chapter dash maven for the IntelliJ. The one that no, the one below. You open this project into a new IntelliJ instance. Yeah, exactly. It will stack upon the other, but you can do it independently. Yeah.
Sorry, I need to clone it to my laptop.
Yeah.
How can I do this? Because I see the link to the code, and this is just an Amazon editor.
Yeah, no. Over here, it's already cloned. If you're using the code here on the Explorer, yeah, it's already cloned.
It's already cloned, but it is in my Amazon environment, correct?
No, it's in some Amazon account that I'm providing to you.
Yeah.
So it's already provided.
So I can do all the
Yeah,
job inside this
exactly,
environment.
exactly.
Okay. And what is with IPK? What should I do? Some
Chapter
chapter 1.
1, yes, and the first class.
I need
And now you have if you scroll down, you have to-dos. And this is your first challenges in the chapter 1. First thing is to create the agent and then to summon it. You good? API key. Yeah.
Where to place it? The API key.
When you will it can be placed in your environment variable in IntelliJ. For example, I think I'm sharing. If you go back to the workshop instruction, in chapter 1, yeah, if you scroll chapter, so you need to open this specific project into IntelliJ.
This one?
Yeah, I think you can open it as a single instance of IntelliJ instead of having the whole project opened. Yeah, it will be easier. I don't know why. Yeah. Yeah. That way you can run it, and you need to put in the environment variable the API key. Should be good. Thank. All good? Oh. Did you get it? Did you connect it to the Amazon Bedrock console? No. Close that one. And go to on the left on the Open AWS console. And now in the search bar, when it will refresh, you can type Bedrock. Yeah, and click on the name. And on the left, you will have the API key. Yeah. And you can scroll down. Generate short-term. No, you should have a button. Generate. Yeah. Okay, sorry. And you can copy, depending on your operating system, the Linux, macOS, or the Windows one. And you can save it in a notepad.txt. Then, I don't know if you're doing via IntelliJ or. Okay, so you need to put it in the terminal. Yeah, you passed in the terminal. So when you will do a JBang your Java class, it will have the credentials from the API key. Yeah. Yeah. You're welcome. Yeah. Yeah, this is what I did. Yeah. Yeah. Yeah, sure. Region for me. Yeah, but if you provide this environment variable, like it's set AWS _region. That's weird. It's asking for it. Should not be the case. No, keep the add a new environment variable and equal US dash west dash 2. Yeah. And okay. Yeah.
So apparently it doesn't work on,
Hmm.
on the other. Let's just see.
No, it says Shen software. That's
Did I make a mistake with the delimiter? So let's just see. I did it with.
I
Is it like this?
yeah. Let's try.
Because I don't really remember.
You're using Java 27.
Yeah,
I
I can change it.
225. I don't think. No, it's not related. I don't think it's related at all to the.
But let's do it like.
But I didn't try. No.
It doesn't really matter if it's, but still, let's do it like this because it's faster.
No, that's different thing. I'm gonna have a look because
Still problematic.
yeah, I'm gonna go have a look in my IntelliJ too, because shouldn't be the case. I didn't get it, so
Sorry, I like logged in with one-time password and it requires login again.
no. Close it. On the left, you have open AWS console. No, not that one. This one. So you're gonna be on the AWS console. I provided a specific AWS account per person, so you can do it on your own. You don't need a credit card or whatsoever. You can just use these accounts.
And how can I get my APK?
This come back. No, come back to the link that we clicked. Click on disconnect on that log out. Yeah, to log out, click here. Click on that one and re-click. Yeah, and now it should be. You will have credentials. Now you're good, and you can type Bedrock in the search bar to get your API key. Yeah, you're on the account that I provided for the workshop. You're welcome. You're good? Okay, cool. You're good?
Shall I install jBank?
On your machine?
Yes.
Yeah, you can, if you pick the JBank path, you can install it. Otherwise, if you're using the code server that I'm providing, JBank is already installed. So if you click on that one, on that one above, yeah, click, and you scroll down. Oh no, sorry. Scroll up over here. Sorry. No, scroll up. Up. Yep. Click on the workshop name. Scroll down. Here. If you click on that one, the workshop is already cloned, and JBank is already installed.
So I can work.
Yeah. Yeah, you can walk over here. You're welcome. All good? Okay, cool. Region? Yeah, the same one. I need, yeah, like I think the same. I'm gonna have a look. Yeah. Yeah. The value is AWS beer token. The key is AWS beer token, and the value is the underscore bearer. Yeah, underscore token. If I'm not, yeah, if you, yeah, you're welcome. Are you good?
Trying to install Java because I'm developing under Java, so I install Java
With JBank, you okay? Because if you install JBank, JBank also comes with. You can pick any default Java version you want, like Java 20. This workshop has been made with Java 25. It works with Java 17, 21, 23. Due to permission. Yeah. But I think that due to the this is a Windows. I guess that's the Windows. No. Yeah, so that's why. You can go to the JBank website. No, this is the yeah. You can see this is the Bash one. So if you go to yeah over here. Yeah. I think it will be better. Yeah, on Linux you have the PowerShell command. Yeah, I think it's the PowerShell is doing both. Yeah. Just open a PowerShell, and you'll be good. You good? Okay. You can install it. Yeah. Not that one. Open over here. Yeah. If you go, so it's one AWS account for each person. And here you can type in the search bar Bedrock. Click on it. Yeah. And then API key on the left. And you can generate and get it, depending on your Windows, du coup. Yeah. You good? Oh, cool. You good? Oh, cool. Yep.
My issue was last time I wasn't being able to log into the.
Oh, okay. And get the API key and okay. How can you save result? Oh, you can clone it. You can use, I don't know. You can go to the workshop instruction and in chapter 0, if you scroll down. Yeah, but I can reveal it. But it's also the part of the workshop to try to implement. I'll reveal it later. No worries. If you go to chapter 1, and I don't know which path you're doing, jBank, and so you have the 2 steps to implement, to code, and I'm gonna live code the chapter at some point. So, okay, everyone is almost good. Just need to check for the 2 IntelliJ and the region. Let me go to my IntelliJ. Yeah. The name of the environment variable was missing. Oh, okay. I can copy just it. Probably. You see, it worked. I did the same. What I did is to modify run configuration, and then I went to the where it is environment variable over here. Yeah, but in fact, I think make sure when you are on the Bedrock console. If you go back to the Bedrock console, make sure that it's okay. It's the same. Okay, that's typically the error that you can face, because getting the API key is regional, so it's from that specific region. And if I'm putting Okay. Doo-doo-doo. You are on IntelliJ, if and is it working for you?
I'm facing issues because I had no Java 25
Okay.
and
And yeah,
project boom
and now
on this enable preview. Not sure if you've seen it, but I'm troubleshooting now.
yeah, but
It's because I was using Java 21.
yeah, but it should work in Java 21 too. I mean, you got some dependencies issues because it's using Spring AI 2.0, but in preview, as the release of 2.0 is not yet released.
I'll troubleshoot.
Okay. But you should. If you copy,
If I do modify one configuration, and we can nicely see
and underscore.
underscore.
Yeah, it's
This is the problem here. Let's just do it like this.
we're gonna make it. Yeah.
Now it's
Now it's normal because you have to develop the to-do, so it works. It works.
this is working.
Yeah, yeah. Congrats, we made it.
token inside the Amazon environment because in Amazon,
Your API key.
yes.
So in the terminal, you can if
Ah,
you can just pass.
export.
Yeah, you can directly copy
Yeah.
and paste the value. Remove.
Just without export.
Yeah, because the export is already written,
Ah,
so you can just paste it. No, you can close it. We don't care. You need to allow. Yeah, and press enter. And now you can do jbang your Java class from chapter 1, and you should be okay. Okay, nice. I see. I like this code. I like it. We almost done. Chapter 2? Chapter 1 is complete? Congrats. Nice. First AI Game Master is alive. Okay. Nice. Yep. Eval is not considered as name of stable. I think it's because it's is jbang in your path. Yeah, default set to 25 eval. Now if you do Java dash dash version or Java dash version, I think the eval we don't. Wait, yeah, missing the blank space. Oh, it's not. It doesn't switch to. The eval is just to make it permanent in your. Can you close your terminal, your PowerShell, and or open a new one just to check? I think it's the same, but I'd like to check. Yeah, I think the command. Yeah, it's already installed. And press enter. Yeah, because it doesn't put into your. Go to the jbang documentation. And yeah, on Windows, because it's due to the. We just want to add it into the path. Maybe jbang. Running. No, we're getting started. Maybe they provide installation and yeah, edit the path, but Windows PowerShell. This is for the insta. I think it's gonna say it's already installed if you do it. I don't remember how to add. Maybe we can type it instead of doing the eval. Add to the path. This is what we want to do. We just want to add to the path. No worries. On Windows, I don't remember. Let's Google it. Type no. Should here. Type jbang path Windows. Think. Can you execute that if you scroll up? That one. Oh, it's already in the path. So let's give a try now. Even if it's 26, that's fine. Let's give a try and run the first class. If you go to the Git project that you cloned, and open a terminal, and now you can do jbang chapter 1 slash slash dungeon and tab. You can tabulate. You can do tabulation to and run it. Yeah, because it's not in. No, it's not in. It's just deduct. It's not considered in your path within this specific terminal. Can you switch this terminal? Yeah, not. But it's gonna. I think it's gonna launch another PowerShell terminal. Would like to launch. Run pass the command that we made from the installation. Because I don't know why it's not being added to your path. It should be added to your path. No. Pick the Windows one because you have a Windows machine. doo-doo-doo-doo-doo. Okay. Let me kill our wonderful agent. So I think some of you have already the chapter 1 and the AI Game Master up and running. So if that's not the case, don't worry. Go at your pace. So if you prefer to go fast, go fast. If you prefer to go slow, go slow. Enjoy it. That's the most important. I'm gonna do it so we can see how we can bring it to life. So previously it was working, but I'm gonna kill it. Zoom a little bit. Okay, so I'm using IntelliJ, and I've only the chapter 1-Maven opened in my IntelliJ, and we can see some stuff about the API key, so it's checking that we have a valid and existing API key in our environment variable, so we can use Amazon Bedrock and summon an LLM, I don't know, like in this case, Cloud IQ 4.5 that we are using. So we are creating a Bedrock runtime client, which allows us to connect to Amazon Bedrock in a specific AWS regions with the credentials from the API key. We provide a model ID, and this model ID is the one from Anthropic. Then we create our Bedrock chat option, which is a class that allows us to specify the model we want to use. And we can also provide some parameters like, I don't know, temperature. If we want to set the temperature of a specific LLM with our AI Game Master, we can set to, I don't know, 0.7. 0.7, temperature is between 0 and 1. The closer you are to 1, the more creative it will be. And the closer you are to 0, the more deterministic it will be. We have then a Bedrock proxy chat model. This is our final object from Amazon Bedrock and the AWS SDK in Java, where we provide the Bedrock runtime and the option that we specified for our LLM, so Anthropic and the temperature that we set. And now we need to use the power of Spring AI to bring an agent to life. So how can we do it? We have the chat client class that we can use. And I'm gonna name it Game Master. And this Game Master is gonna be created thanks to the chat client. And we're gonna use the builder, and we can provide a chat model. So here, this is truly important because with the chat model over here, in fact, here we are using Amazon Bedrock, but if you want to switch to, I don't know, an Anthropic subscription that you have, an OpenAI subscription that you have, you can definitively switch in the builder from Amazon Bedrock to any other provider. If you want to use Ollama when you are developing locally, for example, then you can switch from Bedrock to Ollama and use and consume your agent locally with Ollama. Okay, we want to provide a personality to our agent. So when we want to provide a personality, we have the default system method that allows us to provide, in fact, a system prompt, a persona, some instruction to our agent. So you are a game master in a heroic and fantasy role-playing game. Be creative and play with players in the room. Okay, and once we have that, then we can build our agent. So we have our agent here. This is an instance of an agent. It has no tool yet because this is the first chapter. But we get an instance of our agent, and how to summon it? Well, it's simple as gamemaster.prompt. So we want to prompt it, and we want to provide some input to our game master agent. So we're gonna use the user, and the user is gonna be your user prompt. So hi, I am ready. Oh no, I am going on an adventure, like Bilbo would say. Great. We provided the prompt, and then we need to call our agent and to summon the agentic loop. So it's the .call method that we can use. And to get the result that we want to just to display in our terminal, then we fetch the content. And that's it. Good. Once we implemented it, we're gonna print it, io.println, game master says io.println response, and let's see if it works, if we still have a valid API key. Yeah, it works. Game Master says, "Welcome, adventurer. The tavern falls silent as you push through the heavy wooden doors. The bartender looks up with a knowing smile. Okay, fresh blood, another soul seeking glory and fortune. I see. Okay." So this is the first chapter, and you can see how simple it is using Spring AI to create your first agent. And this agent then can be integrated in your application. It's not coding agent that we are doing. We are doing agent that's going to be placed into workloads that we implement. So that's the goal of the first chapter. And now, if we are moving on, chapter 2. The chapter 2 is to provide some built-in tools to our agent. So we're not going to recreate the agent, but instead we're going to add some tools to our agent. And what's the purpose of chapter 2? We need to add tools for sure, but in the end, we need to get some information about the creator of the most famous tabletop role-playing game, which is Dungeons and Dragons. Okay, so let's do it. Chapter 1, Nano, okay. Yeah, sure. Yeah. Yeah, absolutely. In this case, in this specific multi-agent application, we would set it to 1 on point 0.9 because we want to be as creative as possible. Yeah. And I would say sometimes we won't know what's going to happen. You're welcome. Smart Web Fetch Tool. Okay. Chapter 2.
Yeah, I'm done, but I'm trying to do some.
Markdown is how the tool is gonna be is gonna is it it's like it doesn't share about the reasoning of the LLM itself. It says, okay, you as an LLM, when are you capable, or when can you use my tool to achieve the result, with some usage, some parameters, the contents length. I'm going to chapter 2. So yeah, go ahead. Yeah. It's yeah, slash slash depths, because in JBang you need slash slash depths. You see, yeah. In fact, JBang resolve dependencies using, and then you import it. That's correct. And then you need to, yeah. And this is, yeah, normally you have a dot tool method that you can use. So this is your, where is your agent being created? Here you need to provide a tool to your agent. So how to provide a tool? Then it's a dot, yeah, dot tool. Tools, yeah, tools, it was tools, correct. Yeah, 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 I'm gonna showcase. Yeah, yeah, I'm gonna showcase it. Because matter of time, just to make sure. So, chapter two. Um, how many of you have completed chapter 2? 1, 2, 3. Ah, most of them. Okay. So, in the JBang path, when you want to import a new dependency, in your favorite pom.xml, you will add the dependency block. Here, you add the slash slash depths statement with the ID of the artifact plus its version. So you can see that we are using Spring AI 2.0 M4. Hopefully the release is going to be soon. The AWS SDK, and then once we declare our dependency, like we will do in the pom.xml, we import it. So we import our Spring AI community agent tools smart web fetch tool. Okay, that's great. Then we have the same thing as in the preview, in the chapter 1. We have a Bedrock runtime. We have still Cloud IQ 4.5. We have a chat model, a chat client. So we have an agent. So everything was created. The step we were asked to do was to implement the Smart Web Fetch tool. And how to do so? Well, we invoke the Smart Web Fetch tool class. We provided it to our agent over here. We can set a content length because we are browsing the web, so we don't want to fetch everything on the web. And we build it. So once we created the Smart Web Fetch tool object, we can just pass it to our agent. And how can we pass it to our agent? Then when we summon our agent, agent.prompt.user with a new prompt, in this case the prompt is use the website of Wikipedia and the Dungeon and Dragon webpage to tell me the name of the designers of Dungeon and Dragons. And here, this is the key things. We have the .tools method that can be used when you are invoking your agent. When you summon your agent, then you can pass the .tools and reference as many tools as you want to your agent. In our case, we have only one tool, and we just print the response. So importing the tool dependency and the Smart Web Fetch tool, in this case, creating the Smart Web Fetch tool instance, and then attaching the tool to our agent. So let's see if that works. Chapter 2, oh no, chapter 3, chapter 2. JBang, Dungeon. I don't think I have an API key, anymore. API key. Okay. So can take a little bit of time depending on the network. Okay, it used the tool. So you can see in the logs, I think you got the same, like it used the tool. It truncating to 300,000 characters. And agent's response based on the Wikipedia article on Dungeons and Dragons, the designer of the game are Gary Gigax and Dave Arneson. Okay, so in order to fulfill our request, which was this specific prompt, it used the tool we provided autonomously to achieve the result. That's great. So now, for most of you, Chapter 3. Chapter 3, we have an AI Game Master. We used a built-in tool in Chapter 2. Now we want to create our own tool. We want to create a custom tool. And this tool is a tool to roll the dice. Yeah. Do you have, I think, yeah, if I remember correctly, spring-ai-agent-utils. Yeah. No, that's 2 dot for the version. Yeah.
In general, when you declare tools, we have the dice tools. Can you declare
Import org.springaiCommunity.agent dot tools dot smart web fetch tool. Is that correct? Versus what you have versus. For those that are using JBang, also if you are interested in, there is an extension that you can install on IntelliJ or on a VS Code like, and it will resolve dependencies, also highlight the dependencies, so it can be useful. If I go back over here, and then I can get the detail. Up. And once the import, then I set on the web fetch tool declaration. So you, yeah, I think you're good. And then you provide the dot tools. Yeah. So I think now. Ah. Three, this is where it also start to becomes interesting, because in chapter 3 we have to import the tool and tool param decorators from Spring AI. So we did, I mean, things with built-in tools, but when it comes to building our own custom tool, we have Spring AI decorator that we can use to ease the process. And that's really, really key, because then we will be able to have a dice tool. So we have a dice tool class, and then we're gonna create a rolling dice tool, which is a simply random function, but it works perfectly. And our dungeon master, our AI game master, will need the tool. And I think I'm not spoiling the answer if I'm just sharing that the dot tools is gonna use the dice tools class, but the secret sauce is in the dice tools.java. Come on, I know you can do it. come back with the stickers. Stickers. Stick. Stickers. There are many. Yeah, you think you can take many. No, feel free. Yeah. You're good? Okay, that's. You're good? Or you want additional ones? Yeah. Come on, come on. I think there is. Yeah. Wait. It's somewhere. chapter 3. Who is done with chapter 3? Oh, few. Oh, nice. So chapter 3, you've seen that you invoke the tool with the dot tools like we did in chapter 2. And in the dice tool class, we used the Spring AI decorator to be lazy, let's call it. And we love to be lazy as programmer. So we have a add tool decorator where we do provide a description of our tool, roll the dice for D&D game mechanics, use this for attack rolls, damage, ability check, or saving throws. And we have an existing function that we can use, roll dice, that's gonna roll the dice using random library. But we also have the tool param decorator that we can specify in order to let the LLM knows how to use this specific tool, function in this case, and how to invoke the function with the right parameters, and if these parameters are required or not. So we can see that the two, like the faces of the dice and the number of time we want to roll the dice, and it's returning the record about the rolls, the number, the total we got, and the description. Rolled, I don't know, 3d6 and got the following result. So let's give a try. If we go to chapter 3, JBang, Dungeon Master with custom tools. And the prompt from the Dungeon Master is like, "You're Lady Luck, the mystical keeper of dice and fortune. You speak with theatrical flair. When rolling ability score, remember the traditional method, roll 4d6 and drop the lowest die. Okay, help me to create a new character, roll the strength wisdom." And what did I get? So the AI game master or agent used the tool autonomously in order to calculate the different ability of our character, and I got a 13 in strength, 11 in wisdom, okay, not that really good, 11 in charisma, and wow, 7 in intelligence. That's hurt. But okay, I'll take it. Your character may be more muscle than mine, and even the game master is joking with me. So that's pretty cool. Now you have an agent with a custom tool, not just built-in tools, and it's using it autonomously, and thanks to the Spring AI decorator, we can do it pretty easily. So now, chapter 4, I don't know if we will have time because there is only 15 minutes remaining, but chapter 4 is to pack our custom dice roll tool as a MCP server. We want to build an MCP server and to expose this specific tool over the network. And for the one that are doing on IntelliJ, you probably seen there is a Maven client and a Maven server for chapter 4. So two things, because MCP, the Model Context Protocol, has a client-server architecture, and so the client is going to be our AI game master, our Dungeon Master MCP client, but we also, before having the client connected to the server, we need to implement the server. And now we have an application.properties where we need to implement the MCP server configuration and the MCP server itself. So it's a Spring Boot application, basic Spring Boot application, but then we need to leverage the Spring ecosystem. So that's why we can see the integration between Spring ecosystem and Spring AI, because we're gonna reuse the Spring ecosystem we are familiar with, like components, for example, in order to expose our dice tool over the network via MCP. So let's try to achieve the chapter 4 in the 15 minutes remaining. And the environment are available until Saturday evening, so you can still enjoy the workshop even after these 2 hours. And the GitHub repo won't disappear, it stays on GitHub, so that's pretty cool. Okay, chapter 4, let's do an MCP server out of it. No, normally there is, this is the dependency.
Yeah, I'm saying we don't have a dependency, so it wouldn't resolve the library. It wouldn't resolve stuff.
Oh yeah, yeah. Oh, you think check the model normally?
It's saying that you need to look here. I don't know. I'm just importing everything because I don't know.
Yeah, yeah.
I can't be bothered. But if I don't have the dependency, it just can't find it.
Yeah, that's so. I think that's also a thing. I don't remember in the if you go in the instruction of the chapter 4, it's just the import. Because you are doing the application dot, yeah, and then you are going to the, yeah. Good point. Thank you very much for the feedback.
Was the plan to have everything ready? Because I feel like still in the beginning. Was the plan to have everything ready in the beginning of the workshop?
Normally yes, but it depends on
How many chapters are there?
5. Yeah. So it's like more than maybe 2 hours, 2.5 hours.
I thought we have to build the
No, no, the UI is already available and provided. It's a React application. You don't have to. The focus is really Spring AI and agent, not the UI itself. Yeah, you're right, because I do have the import. I do have the import right here. File open. MCP. Oh yeah, that's too small. You were on the client, right?
Yeah.
Yeah. It's running out of time. So just to let you know that the workshop remains available. I mean, the AWS account that you get access to as part of the workshop remains available for the next 72 hours. So you can play it, I don't know, during a conference, at home. You have 3 days to complete the workshop. I would love to get some feedback of you via, I don't know, LinkedIn, for example, if you completed the workshop and had some fun. Just before leaving, thank you very much for taking the time to participate in this workshop. And if you love this kind of content and would like to see more, like we say at Amazon Web Services, feedback is a gift. So it's anonymous. It says which kind of content do you like, and would you like to see more of this content? I don't know, on workshops, talks, live streams. So any crazy idea that you have in mind, feel free to share. It's anonymous. And so it will help me to focus on this kind of content to improve and make better workshop or make better content. So thank you very much. I hope you enjoyed. And if you have any question, feel free to ask right now. There is no silly question at all. There is no such thing as a stupid question. Take stickers. If you don't took stickers, take stickers. And I hope to see you in Sofia or on LinkedIn to be in touch in the future. Thank you very much.
Да, точно така. Момчетата от последния чин, както, както в университета ми. Да, в университета така не се караха. Чао, чао. Куста, бе. Дали да изчакам още? Май резолюцията не е много хубава.
Чакаме ли още? Скоро ли свърши последното? Мгм. Мгм. Добре, да започвам. Да направим проба на звука. Има ли нужда? Чува ли се? Не разбирам, аз не чувам. Не работи? Аха, добре. Добре. Май не е включен. Работи. Работи. Моля, по-далеч. Добре. Да, чува ли се? Добре. Чува ли се? Упс. Добре. We will start. First, I want to share you that the last 20 minutes I had a conversation with one old guy from the security guys over there, and he explained me that the artificial intelligence is bullshit. so I don't have now. Welcome. Thank you for coming, and welcome to this webinar implementing agentic RAG using Spring AI. My name is Jordan Yovkov, like the famous Bulgarian writer Jordan Yovkov, but I'm writing on Java. But the truth is that for the last year, I only write on Bulgarian, on English, write instructions and confirmations. So in this workshop, we will create a RAG system, and we will follow some kind of real life scenario. We will have application, some kind of simulation of real application about store for video production equipment and techniques. And we will add some functionality about RAG functionality about this store. From the beginning, we will create simple RAG, so-called knife RAG, and after that, the RAG will be evolved into agentic RAG, where the agent, the LLM, will make the decisions from which source of data to gather the data from database, by using a REST client API to take the data from different application or from NCP server. And before starting the real work, I want to make some theoretical base and explain what is RAG, and we will start this. RAG is a technique that combines the power of large language models with some data, some specific data that we have some our data, and in this case the result is more accurate and more relevant. We will use more relevant response, by sending the LLM specific our data. If we look here, the standard flow when somebody asks the LLM, the flow is the user writes the prompt. After that, the LLM is thinking, creating the answer, and returning the response. When we have a RAG, the RAG flow is different from the beginning. After the user question, after the query, before sending the prompt to the LLM, we have a RAG module which collects data from our own sources, and since a part of most relevant data that we had query from the query to the prompt, and the prompt is combined with this most relevant data, and the LLM has the power to create, format the response, having in mind that our specific data and about the question. Now the RAG process is divided in two separate stages. The first stage is called the ingestion phase. It is the phase where we put and collect our specific data. And the second phase is the retrieving our specific data from the RAG with the power of using the LLM. Usually these stages are separated in different logic, and they can be most of the time can be executed separated by execution. For example, we can load the data. We can load the data once a week, but every minute there can be query about our specific data. Now we will take a look at the first phase. The first phase is ingestion stage. And in the ingestion stage, usually loads the documents with our specific data. For example, these documents can be PDF files, some our own company documentation, some documents, some Microsoft Word documents, text files, or so on. And the usual storage of this our specific data in our knowledge base is in vector database. And in the vector database, there are three processes. The first is chunking the documents. It means that the documents are separated by so-called little fragments of data by different criteria. These criteria depends on the data, and it is chunked by the data is chunked. After that, the data is embedding. Embedding is a process where the data is stored in the vector database as how to say it, mathematical representation in vectors, different I forgot the name. And after that the third process of injection the data in the vector database is indexing. It is preparing the data to be extracted after that. The second stage of the RAG is the real-time query processing stage. This stage has three logical phases: retrieval, augmentation, and generation. How is the right abbreviation? The abbreviation, thank you, of these three phases, logical phases, is RAG. Here the retrieval is when the data is collected from the vector database, from our knowledge base, and the collected data is the most relevant data which we are acquiring and which is stored in this query, this knowledge base. After that, when we have most relevant taken data from our vector database, the next step is to augment the prompt. As I said before, for some minutes, the prompt has more data, the most accurate found data in the retrieval process. Now the prompt is the question, the query, and I will show the examples. And after that, after this query, there is here is the found result from the knowledge base about our query. After we pass the prompt to the LLM, the last phase is generation. The LLM generates on base of the prompt and the retrieve information from the knowledge base. The LLM creates the response. Here is important which LLM we use. If you use a clever LLM, the response will be better. It is obvious. Now I will mention some method of RAG improvements, and I will mention them fast. And after that, we will go to one of the methods, which is agentic RAG. There can be make improvements of RAG systems. The improvements can be made in the different phases of the logical phases of the RAG process. For example, here is this method is contextual retrieval. It has contextual info about every chunk. If we take a look here in this, when we write every chunk, we can add info. We can use the LLM to write specific info about this chunk, and in this way there will be a metadata which is more useful about this chunk. And this gives us the ability to the retrieval process to be with better results, because we had structured contextual data as a metadata in every different chunk. Another part of the logical phases where we can optimize the rack functionality is by improving the query. If we look, for example, here, if the query is more optimal, is better, it is obvious that the whole result will be better. So that we can use the LLM to enrich every query, and if the LLM decide to enrich every query, the results will be better. Here are pros and cons about that the results of the retrieval will be better, but we will make many calls to the LLM. Another way of improving the rack functionality is creating multi-queries. This method I will use in the project, and you will see how it works. With this method, with the help of LLM, we create several queries according to different data. You will see that we work with our documents in the projects are about different video editing cards for digital video editing, and in an example we will have several queries about every video editing card. Another way of improvement the rack functionality is by re-ranking. The re-ranking is process after I will show here. After we will have response, after we will have about every query have several. For example, if we have several queries, we will have different responses. And the ranking is a process of checking all the responses, and by additional call to the LLM will decide which of the returned responses has the best answer. We are calling the LLM to decide and to have a better result. And now we are going to our topic, rack improvement. It is agentic rack. Agentic rack is a way of have an agent which is capable of collecting the data in the here is diagram. The agent collects the data which we query from collecting data from different sources. The agent is capable to make a decision which source to call, and it is capable to make as needed calls to the different sources until it decides that the received result is well done. So with the agentic rack in our application, the agentic rack will collect data from database, from different application by using REST client API, or from MCP server. And now, after this theory basis, we will go to the real project. Now for the real project, there is users workshop guide, which is published in the page of the workshop in jPrime. Is there anybody who had download this file and open it? Okay. Okay. No, this file is just a second. This file is 12 pages, and here is everything described about the project. Now, to say something about the project. The project is, imagine that we have real-time product stock, which is video production store. Video production store is some kind of simulation of real store, which from here I will show you after a moment. This application is for the availability of some video editing cards and customers and orders that the customers have made about these cards. And after that project, maybe now first I want to mention why I had choose this domain topic about video production, video editing cards. I have worked as these guys over there as video production industry between 1995 and 2005 year, and I found that most of the LLMs are not capable to give a good answer about video editing equipment and techniques before 30 years. And so we will check that the LLM is not capable to give an answer, a good answer. It will hallucinate. I will show, and after that we will use our specific knowledge base with users' manual technical specification of some of the cards before 30 years that we used to make video editing, and that's why I choose this domain of the project. I have been working as video editor, sound engineer, and director on air in some of the televisions, Bulgarian televisions, before 30 years, 25. And now I want to show you, first I want to show you the documents of our documents which we will use in our knowledge base. For example, here is Move Machine Pro. It was one of the best techniques from 1994. When I was young. Another is Media Storm, Media 100 in English. Media 100. It was one of top of the video production in some of our televisions. It is interesting that these documents are difficult to find in the internet. There is no data about these techniques, and DPS velocity, mirror motion, that's 30, and some document about different video cards before 30 years. And here is the computer, supercomputer from this time. And now we will take a look at our base application where we will start. This application is Video Production Store. If I start this application, first to start it, I want to mention that there are 5 projects. I will explain and we will go through them after a while. But Video Production Store is the simulation of Video Store. The specific about this project is that this is there is no Docker container. Just a minute. The specific is that if we take a look at the here in the guide, it is explained about this project. This project is how to close it. How to close it? I don't know. I will open it. And the specific about is that this project is a simple REST project with REST API for creating 4 domain objects. These are video editing card, stock availability, customer, and order. And the data is preloaded in the database with Flyway. The data is stored in the database in this format. There are 4 video cards with their description, the manufacturer, and the price of the card. And stock availability shows which video card, how availability there is of which video card. Here are some customers which are with fictive names: Ivan Ivanov, Peter Petrov, Georgi Georgiev, and so on, with their own data as email, phone, address, and notes. And there have been made an orders about some of the products. The orders describe which customers have buy different video editing cards, and on which date, and some note if there is some note on the purchase of the order. Now here is the list of API. I will show you the API after a while. What's going on? Yesterday it worked. Why there is such a problem? Aha, this container is running running. This application will be the base of where we will take the data. But why there is another problem? Compose. I found this problem is solved by closing the Docker. Let's open it again. My idea is to create the project. There are seven steps to create the project and the project to evolve in the next sequential space of development. You will see all the steps after a while, but the first thing is to start the main application. Sorry. It was not planned. I think that everybody had such kind of moments. Yesterday it worked. Sorry about that. Oh, it started. I closed the Docker, closed the IntelliJ, reopened them. It started. Okay, we will continue. Here is a Swagger online documentation of this API. It gives us several endpoints about our four objects, domain objects: customers, orders, stock availability, video editing cards. For example, we can test some of them. Video editing cards. It shows that there are four video editing cards. For example, the customers. Just to show it, and it will take all the customers and so on. They have been created several several endpoints about the needed functionality that we will use after a while. After that, we had the first step had our working application, working video production store, and having in mind that there are there is data about orders of video editing cards. We will add more information from our documents about describing these video editing cards. And now I'll show you a demo, quick demo for one of the complex test scenarios, just to take your attention, and after that we will start evolve the project. Now I will start the MCP server. I want to mention that I have created a project, Video Production Store Client. This project is a REST client which takes data from our video production store and using the REST way. And this client is used in our MCP server. Our MCP server, I will show after a while, is MCP server which give us the same data available as this video production store that we found in the Swagger, but MCP server gives the data in a way to be collected from the LLM. And here on the structure of the multi-module projects, in the structure, the most important projects that we will develop after a while are rack and gesture and rack retriever. These projects corresponds to the two phases, two main stages or phases of the rack. The first is ingestion, where we save the data in our vector data store, in our knowledge base, and the second project is rack retriever. We can retrieve the data from the knowledge base to use it. Here in the project, I will open it. I have created seven steps of the evolving of the project, and the first step. No, after that I had to show you how it works. Just a moment. I have started it. I will start the Ingestor application. Only I will show what we want to achieve by developing this project, and after that we will start to take a look at every step of the development. Now I will start rack ingestor and rack retriever projects. I will load the database with the information from these several PDF files, and after that I will retrieve information with some specific questions. Okay, the ingestor is started. After it is started, I will reload the data. We will go in the details after a while. Now I will show you how it works, and after that we will go in the implementation stages and details. Now it is loading the data. our knowledge base. The data is from these documents, the several documents that I show you about specific video editing cards before 30 years. The data is loaded, and after the data is loaded, we can start the project rack retriever to take some retrieval of the data. Why anybody can tell me why I have choose to make different projects, rack ingestor and rack retriever? Any suggestions? Okay, I will tell. Because rack retriever is provides functionality only to gather data from our knowledge base or different sources by using the LLM and agent, and this project is it's stateless, and it can be by creating different projects. It can be make high availability. It can be scaled. It is good practice for designing the software. But rack ingestor provides functionality only to fill our knowledge base with data, so it will be not needed to be available every time. It is stateful, and these two projects have different type of functionality, and it is better to be divided. There can be created one project making this functionality, but it is better to be two projects, and for example, rack retrieval to be scaled. And now we had working application, and there is prepared a document with test plan. Test plan for different scenarios. For example, taking that data only from knowledge base, taking data, trying to taking data which is not stored in our knowledge base, taking data from simple relational database, from multiple relational database sources, from relational databases and vector database. And I have created this test scenario, and about this test scenario we have created endpoints which can be started, can be executed. Now we have the data from our application, from our video production store application, which holds data for the three domains: video editing cards, customers, stock availability, and orders. And we have data about technical information about these video editing cards. And now I will call some queries, different queries from different types specified here in this document to see how it is working. First, we will ask the LLM. We will try to ask the LLM question about some of this one of these video editing cards. Only the LLM, not our rack. Just a second. You will find. I'm asking the question, what is Move Machine Pro? This is video editing card from 1994, and the result is. Take a look at the result. The result is something different. For example, the operation system of this card is Windows 10. Windows 10 in 1994. Windows 11. Quad-core Intel iPad, Ryzen PET, 34 gigabytes of RAM. These times the RAM was 16 megabytes before 30 years. It is obvious that the LLM is hallucinating because there are no information about these cards in most of the low-level LLMs. After that, I will show how I will ask the same question, but we will use our rack. What is Move Machine Pro? Is the question, and here the answer is that this is a video editing card IBM 80. It was a specification between years, being 80 computer. 16 megabytes of RAM is recommended. It shows that it works by reading the data from our documents. Another test is we will ask an relevant question about our data. Where is the pink elephant? And it tells us that, sorry, but I don't have any information about pink elephant. The rack is working properly. Now it will ask a single tool. We will see it after a while. Show me video editing cards, price between 300 and 500 euros. And here the LLM is checking all its sources of data, and he found that in the video editing cards table in a relational database, there is such an information, and it extracts that information about that two of the video editing cards are in this price range. And if we look at the I have created a tracing in the application where I'll measure how to say it, where we can trace the request and the response, trace all the process flow. And here I will sort them. Yes, it is the trace of the last query. Here we can see we asked the question about video editing card in a specific price range, The first one is that it is calling this API. After that, it calls the chat client using the LLM, and after that, the chat client is calling this LLM. I will show you after a while, and a specific tool about providing us the information about video editing cards with specified price range. And after that, the LLM is structuring the answer. Now we will take a look at a more complex scenario. Well, the LLM will use two multiple tools, two multiple data sources according to the question. For example, what has customer Ivan Ivanov purchased? And here the LLM found that Ivan Ivanov has made orders about these two video editing cars, and the interesting here is if you look at this trace of the query, it is different. It is different than the other. The trace here shows that now the LLM is calling two different tools. Find customer by name, and by the given name Ivan Ivanov, it finds the customer, which is the customer according which is the record in the database about this customer. And after this customer, it is checking the orders by customer data source, this table, and after that, here we can see that the agent is capable of make decision according to our data and our questions from where to gather the data. Most complex scenario is here when multiple tools, the data can be combined multiple tools and using our knowledge base, vector database. Here the question is, show me the details of customer with ID 2 and include the purchase history of this customer and the detailed information about the purchased products. And so it give me the result that the customer with ID 2 is Peter Petrov. He had made this order about DPS Velocity video editing card. And here is information about DPS Velocity taken from our knowledge base, which is in the vector store. And if we take a look in this trace of this query, which is the last one, maybe this one, we can see that here the LLM is making more complex decisions by calling different data sources. First, it checks which is this customer by ID 2. This customer. After that, it checks the orders of this customer. It found that the order is DPS Velocity video editing card, and after that, it is searching the knowledge base with vector knowledge base, and after that, combine the answer. Okay, this gives us what we will achieve after developing in these 7 steps that I have I have created. Now I will close the whole project and take a look at every step, what have to be done, and every step will explain how the development process of this agenting rack was. How was the development process? You will see it, and I will explain on every step. It depends of the time, but I will explain some specific problems, some specific taken decision, how the some problems and some solving of these problems. Now, the initial state of this project is multi-module project with the 5 projects: video production store fully functioning, MCP server and REST client fully functioning, but the rack retriever and rack ingester are empty. You will see it. Something specific is that I choose to work with the latest available technologies which are available now, not now, but before a week or two. Spring Boot 4, Java 25 last long-term support release, and Spring AI 2. And I can say, is there anybody who is working with Spring 4? Okay. I can see that Spring 4, there are many problems when you want to use some dependencies, some different dependency from different providers or in Spring with Spring 4. There are some problems because from the contributors of Spring 4, they have decided to make it more with more granularity, more smallest pieces of dependencies, not just by writing Spring Boot starter and so on, but some of these starters are divided into several inner starters, several pieces of these starters. The purpose of this decision is to be the smallest application with smallest dependencies loaded in the project. So this gives me many problems, but with help of my best friend in work and your two friend, maybe, I solved the problems. Now I will show the two applications. Rack ingester is empty. It has only setup OpenTelemetry, which provides us the observability, which I show here about system of logging and tracing. It is setup, OpenTelemetry setup here in the project, and the project is empty. And Rack ingester project, the situation is the same. There is in the initial stage, there is nothing specific, two empty projects. Now, first, in the development process, the second step will be to write some functionality to to be able to call the LLM. And this functionality will help us to see if the LLM is capable of giving some answers about different questions in different domains. How I showed before that the LLM is not capable to give good answers about this video editing cars before 13 years. And here in step 2 of the, just a second. Here in step 2, I have created functionality that uses Spring AI calling the LLM. And the specific here is that this functionality is in rack in Gesture project, which give us the functionality to ask our system. Rack in Gesture is where we ask our system, where we ask our rack. And here, for example, in rack in Gesture retrieval. I wanted to say retrieval. Retrieval. In our retrieval, we have a controller with endpoint task, and this controller is using facade. Here I have used all the best practice of separating the data in different layers. For example, here is domain layer, web layer. The domain layer is business layer of the application. It is separated in LLM specific logic, in observability specific logic. Here the web layer is separated of controller, for example. Here the facade used by this controller. The facade is using the chat client. There we create, with the help of chat client factory, we create a chat client. The creation of chat client is here in this factory, and here is the real client. The real client uses this from the beginning. I have created I have created two types of clients: sync clients and their request response clients, and stream clients. But after a while, I deleted the stream because of the complexity of the project. So there is an interface by calling the prompt, and here is the real LLM client. The LLM client, everywhere in the application there is a logging on every layer, with logging give us useful information what is happening. The client is using created chat client by the factory and calling the prompt. Here is just a simple LLM call. And about that, something specific is about the choosing of LLM, which LLM we will use. Something specific. Every project is runs Docker Compose, and after the starting of the project, they have been creating several containers about that project. Here are configuration properties about the observability, logging, and something interesting is here the choose MML LLM model for chat, and model for embedding. I had created four types of configuration, only using Grok model for chat, using and Ulama, for example, for embedding, Grok for chat, OpenAI for embedding, and so on. Interesting here is that, just a second to find it, the LLM model. Interesting here is that the LLM which I use is from Grok, but Grok with Q at the end. Is there anybody using Grok? It is a very good service provided from this company. I will show it. Here you can use different LLMs, different models, which are run in the environment of this company, and there is a free tier which is perfect from such kind of development, such kind of little application. It is perfect. It is free, and I have prepared in the guide that everybody who wants to run this application can make his own account for 2 minutes, maybe 1-2 minutes, and to use this. This is something like Open Router. Open Router is, I think that you know what is Open Router. It is provided. It is provided service interface for different LLMs. Here you can buy some plan or some quota of LLM calls with tokens, and you can use different where are the models? Different models with something like a gateway for using them. One of the decision was to use Open Router. Here you can use, there is a free tier, and you can use free for different limitation of usage of tokens. These models are, as you can see here, one of the best models. But I decided not to use Open Router because it has limitations that are not will not give me the ability to run and to develop and to show the application. The limit is very low. But the Grok is better about that. This company is hosting free free LLMs, something like Ulama. But they had the environment to run to run some expensive LLMs, not to use, for example, Llama on our computers. And for example, I have bought expensive video card, NVIDIA RTX 5060 Ti for using local LLMs. But after that, I found that the Grok gives me the ability to use better models and free. And this expensive video card is maybe not needed about that. And here are four configuration about combination of LLM for chat and LLM used for embedding. And in the application properties, you can change the profile, and after changing the profile name, it will load different configuration about different LLMs. And here we are using Grok Chat and OpenAI embedding. We use this configuration, and here I use this model. I recommend you. It's a very good model about, according to my experience, it is free by using with Grok. And several times I have reached the limits of this model, token limits for the day, and after that I use this model. This is smallest 70B compared with this bigger 120B, but it gives a good result. And the first stage, the second stage of the project, we had functionality by calling the LLM. After that, we will go to the third stage of the project, where we will create a functionality that is using our vector database, which will be in our application, our knowledge base. In this step 3 of the development process, we will add PG vector usage in the project. Here we will extend our RAC in Gesture project, because he is working with loading data in our vector store. And now RAC in Gesture, you can see here that in RAC in Gesture to take a look at the configuration first. The configuration, something new is configuration for the PostgreSQL, configuration for the vector store. Are you familiar that the new versions of Postgre had the ability to provide us a vector database and relational database? And now we are using one DB PG vector, which is PostgreSQL, and extension for vector database. Here, more specific is that our table which stores the data in in the PG vector is called vector store. It can be called in different names. Another specific is the here is specified the dimension of the embedding. Dimension of the embedding is a characteristics of the of how the data is represented in a mathematical way with vectors in the vector database. How this dimension is bigger, the bigger dimension, the better results after saving the data, embedding the data, indexing the data, and after that searching the data in the vector database. Now something observability logging. Here is about another specific configuration about this project is about the searching parameter in a vector database. There are two most critical parameters in vector database, top K and similarity threshold. Top K means, I don't know if you're familiar with this specific details to skip it. I don't know. Okay. Top K is a parameter when we are looking and finding, searching some information in vector database. Top K is defining which is the number of top most relevant found results in the database according our search. And top K 5 means that the vector database will return five most relevant results according the data, according the set dimension of the embedding when the data is loaded to the database. And this parameter is very tricky and specific about the final result of the rack after the final result if it will if the search will return 5 documents, 2 documents, 2 results about the search inquiry, 2, 5, or 10, for example. It depends on the data. It depends. I will show you after a while with the examples. It depends on the data, how the data is structured. And one thing that I want you to tell you that when working with vector databases or working with RAG, when we want to create RAG functionality, there is no silver bullet to say it. The result depends on the data, how the data is structured, and how these parameters are fine-tuned about the data and the result. Yes. It depends of the data, how the data is chunked. We will look in the code after a while. Algorithm of chunking the data, how the data is, what is the nature of the data. Here, for example, if I open one of the documents in our database, for example, DPS velocity, it is some kind of document, some kind of brochure. Maybe it is only seven pages, and the the data format, here you can see, Windows Media Player, you can see that the data is structured in some presentational way. But if I open another document, for example, here in this user's guide of mirror motion DC30, you can see that the nature of the data is very different. It is 70 pages user's guide with technical specification of the video editing card about some specific installation in the computer, how to use it. The nature of the data is different. So according to the data source, according to our data, we must fine-tune these parameters. There is no one way to, no one right way, no silver bullet. The result will be defined after some проба грешка на български. How? Huh? Trial and error. And that's for why there is specific endpoint in next step 4, where according to the given question, the question is, for example, we had 4 documents with different data structure, with different data about video editing cards, and the data is not extracted from all the documents. For example, the LLM is decided, it says, I'm using knowledge database service for searching and extracting data from our vector database. I found here, for example, 5 or 10 results in one of the documents, and that's enough. And if we extend this parameter, for example, to bit 20, here the problem is that we will receive many pieces of data which can be not relevant of the question. There is no one way to do it. Just try according to the data. And if there is no one way with one that the data can be extracted in one with one query, we can use some of this just a second, some of these methods which I mentioned about extracting different data, different nature of data. For example, multi-query rack, which give us with usage of several different queries according to specific data in the specific documents to receive different results, and after that, on the final stage, the LLM to combine the results according our willingness to have the results. And I wanted to share my experience about this settings parameter. The similarity threshold is a parameter which define how similar is the the how is the search result how is similar question and the data retrieve data. For example, if we are looking for a car, another similarity will give us bus, will give us bicycle. It is similar. It is moving. Give us moving way of moving, but it is not a car. And these parameters are very important. And here are the parameters, another interesting parameters about the splitting of the information, about the chunking process. It is, for example, if I open one of these documents, I will show document here in Move Machine. Here is about the hardware requirements about using this video editing card. And it says that it runs the minimum configuration must be processor CPU 486. This and now and another specific requirement is 20 megabytes of RAM, not gigabytes, megabytes, and video card VGA with analog monitor. And when we are saving the data in the database, vector database, the process is splitting the data of parts called chunks. And for example, about this paragraph, it is important how the data will be chunked. For example, it will be a great scenario if this data from here to here is in one chunk. Because after searching in the database, when you write which is the minimal processor CPU requirement for working with this video editing card, it will return this paragraph. But if the chunk is, for example, in this way, selected text, the data will be not extracted in the searching process in a beta format. So the chunking mechanism of storing the data in the vector database is very important. It depends of the data. Sometimes it is, for example, here is this chunk size of tokens. It can be smaller or bigger. It depends on the data. And I had many times playing with changing these parameters, and I found different results. Some good, some bad. I want to say you that when you're storing data in vector database, to have in mind that the chunking is one of the best, one of the most important things in Bulgaria. It is very important because the data will be stored in a good way of extraction after that. And it depends of the data. And here the problem in rack system is that, as I showed you, that different documents have different data and different structure. And here is very complex and difficult complex process to find a way to be able to extract data in this format, this format, and so on. So many tries and errors. Now, we had in step 3, version 3, we had database, knowledge base functionality working with our vector store. Here the interesting is that in the code we had configuration, it is not important now. Here is the ETL extract, transform and load process defined. Here in the service, it is one service in the business layer working with the, yes?
So you gather all your knowledge in these PDF files.
Mm-hmm.
Or,
Yes.
yeah, let's say I have some knowledge
Mm-hmm.
running in PDF files, so I assembled them
Mm-hmm.
myself or something. And then this transformer and this whole thing will put it in the vector database.
Yes.
And then the AI will use it from the
Mm-hmm.
vector
Mm-hmm.
database. Is that the idea?
Yes, the AI will use it, but here we have a functionality only to make some search in the vector database for some testing purposes to see that it is working. And after the next step, the step 4, we will set up the LLM to use the knowledge database as its own advisor. And here we had functionality of load all documents, clear the vector database, load documents, the public method is reload knowledge base and search. The reload database uses this ATL process reader, transformer, and writer. The reader reads the data in some format, DOM format called documents in Spring AI specific. And for example, document here. Here it is class document. It is standard standard as a DOM representation of the document. This keyboard is I don't use it every day, and the keyboards are replaced. So the data is loaded. After that, the data is loaded in memory as documents. It is transformed. Transformation is splitted the data. With transformation process is divided by split it and enrich the data if it is necessary. Here is the splitting of the document magic here this magic happens. And the data from the documents on a final stage is saved to vector database with a specific embedding. And now we have the data in the database, and here is a document reader service which reads the data from vector store, and it had a writer. But the reader reads the data. It reads the data, uses metadata. Metadata, I have choose this for information about the file size, file name, and so on, part of the file, to have a metadata in every chunk. It can be useful when we search in our vector store after that. And in this stage of the project, stage 3, version 3, we had functionality. Here is the test file with the endpoints. We had functionality for reloading the database. I will with executing, but what is happening? Connection refuse. With executing of this endpoint, what is happening? Oh, I haven't started the application. Racking ingestor application. I will load the database. After loaded our knowledge base, after loaded knowledge base in our vector store, I will show that how to search this information, and after that we will go to the next step, next most interesting step, creating naive rack, simple rack. Just a second to start the application. Application is started. I will clean the console. Now, I want to search our vector store with this question: what is Move Machine Pro? And the result is there is no result about this question because the vector store is empty. Yes, it is empty. I will run this endpoint for reload the vector store. It will load here these documents, these 4 documents. After finishing execution of this endpoint, I will call the this question, and we can see that there are answers. And here there are 5 answers from our vector store, 5 most relevant, depending on this top K5 parameter. Yes, and I will ask question how to drive a car. This information is not in our vector store, and you can see that there is no result. Now stopping this project and go to the most interesting part, simple rack. I will stop it, and we're going to simple rack and agentic rack. To most interesting main part of the project, but we had to pass this process from here to here. Now the specific usage when we have simple rack. I will show how the simple rack looks like. To simple rack looks in this way. It means that we have a query prompt in from the beginning, and after that query, according to the query, we will search in our knowledge base. In it is our vector store. We will search in our vector store about the question given in the query, and after that, with the received information, it was, for example, in the last stage of the project, you saw that there are five chunk of text returned, 5 chunk of text, and in the real world, with the real prompt, with the real query, with the real prompt, and with combined with this 5 chunk of results taken from our vector store, everything is combined and passed to the LLM, to the main brain, and the LLM, according to this received data, this received data from here is creating a good answer from for a good response. And here we will see how it happens with rack implementation, simple rack implementation. Here the specific is that we are working in our rack retrieval project. It gives us the functionality to retrieve the data, where we can ask these questions. Our retrieval project, I will start it. And when it is starting, I will explain what is happening on the next step. Here, we must make functionality. When we ask the LLM to use some additional source of data, it is our vector store. And according to the given question in the query and the existing data in our vector store, this data is combined, passed to the LLM, and LLM is creating resulting good format. Here, what is specific? I'll open the just to see if it is started correctly. Yes, it started correctly. I will open the rack retrieval project. I will open first the configuration to show what are the new add-ons in the configuration. The new add-ons are Spring Data Source. Here is a Spring Data Source. It is configured the LLM to use this source. You will see after a while. Vector configuration. Here the vector is configured with the same dimension as the dimension the data have been saved in our vector store. I had big issues forgotten this with different value. And another observability logging. Here are some configurations specific for the naive rack or simple rack. mm, here is the class path of the prompt. We will take a look at the prompt. It is very important. The prompt here in the rack, the prompt, how the prompt is sent is are very important about the quality of the result. The first version of the prompt is, for example, what is Move Machine Pro. It is the input prompt, but the prompt which is sent to the rack in the step when the collected data is sent to the final sent to the LLM. The LLM to be able to produce the result. This prompt is combination of the received data, given good instructions what to do the LLM according to the given received and linked data. You will see after a while. Here is this parameter. These parameters are again existing. They are in a different place, but had the same смысл, meaning yes, same meaning. Thank you. Here is a template for a specific data. We will see it after a while, and here is a multi-query. We will take a look at this after a while. Here to show how it works. We are on version 4, naive rack. But I have created on every step of the development process to have a different containers, Docker containers, to be able to work in the different stages separately. And here to have data, we must start once again this project rack in Jester and load the data, because the data is not existing in this container. And after loading the data, we can use our rack using the LLM with additional source of vector database. Now this project is started. I will reload the database. It is very important to have data in our database. And after that, the database is reloading. We will ask the rack with this question. For example, it gives us a good answer about this video editing card taken from the vector database. Now, what is specific in the code? In the code, just a second. In the code is specific that here we had defined sync client. We had defined simple naive chat sync client. This is the interface, and we had simple LLM from the previous step 3. Now we had different implementation of this chat client, which will be NAFRAC. And here the chat client from Spring AI is creating different chat client, which here the specific is that this chat client have an advisor. It uses prompt, but it has advisor. Are you familiar what are LLM chat client advisors? Okay. Advisors are some kind of how to explain. Chat client had some buddies which can collect data from different sources, and advisor can be configured from where to take the source. It is to set the chat client which will chat with the LLM from where to take some additional information, and you can add different advisors which give advice of the chat client with different data source. Yes, yes, good question. Yes, the tools are define some functionality which is described. I will show in the next stage, stage 5. The tools define functionality which is capable to be taken from large language model by its description. Tools is something like, for example, something like an API, but this API endpoint, for example, but this endpoint is described with some text description, and the LLM, according to this description, can decide yes, if to use or not to use one of the available tools. Yes, the advisor will be called always. It is set to the chat client, and always will be called, and always the chat client will process. I had some information. I have this advisor. Let's take a look at his data. I will use it, and if there are several advisors, the LLM chat client will use all of them. But if there are tools, we will see them in the next step of the development. If there are tools, the LLM will check all the tools, check all the provided functionality from these tools described by their description, and we'll take a decision if to use some of these tools, only one tools for yes, we'll take decision if to use this tool. And if we go back here, here we have an advisor which gives additional information. And here the advisor is constructed. Naive advisor is constructed with this factory. This advisor is created from the first creation of the bean is cached, and this advisor is using using vector store. Advisor can use different sources of data. This uses vector store. And when we ask the LLM will use every time in every call will use this advisor, but this advisor goes to the vector store, retrieves the data, retrieves the data, and all the collected retrieved data will be combined in the result from the LLM. Now we will take a look at the prompt. One of the things very important is how the prompt is structured. Here the prompt is in ifrac is more simple, but in the next version, which is Agentic RAC version 5, the prompt every line of the prompt, if it is different, the result will be different. I will show here the prompt. This is the prompt for the naive RAC, and it combines two sources: the original query, which is, for example, what do you know about Move Machine Pro? And here it is there is set the context information. It is describing that this is the context. This is the context. This context here is inserted. Here is inserted the retrieved data from the 5 found results from the vector store. This data is inserted here. It is big data according to the results, and after that the prompt has instruction how to react according to some properties. For example, here it is very important use only answer only the same language, or do not answer in the given context language, only answer in English, for example. I had situations when loading document for video editing card in Italian language. I found such document, and the LLM sometimes gives me the results in Italian, sometimes in English, because it is non-deterministic. It is working non-deterministic, and you're not sure what will be the result, the final result. That's for why there must be written some instructions. Do it only in this way, do it in this way. Do not make, for example, information outside the provided context. For example, when I ask where is the pink elephant, it was the LLM was stopped from here. Don't to try to hallucinate to try to find some answer clearly. If there is not information content pointed, and the instructions are very important. They depend on the data. They can depend on the data. As I mentioned, that I had a document in Italian, and the results were non-deterministic. So this list of instruction can be enlarged if you want some specific data, and if you want to improve the quality of the result. And now let's go to the most interesting part, agentic AI, agentic RAG. In the agentic RAG, the specific is that we will not use advisor as it is used here. Here we used advisor to advise using our vector store. In agentic RAG, the specific is that the prompt is the same, but here we said the system prompt. System prompt. Maybe you know that there are different kind of prompts. Prompt and system prompt, which holds the system level instruction. You will see it in this version, and in this version we will work with database according to our documents. Our database from the vector data. Video production store. Yes, sorry, but I have tired of speaking. Just a second to load the database. Here is the interesting part when we have agentic RAG. And the next steps are the agentic RAG to use HTTP client to have a distributed system to call the data from another application. And the next step will use MCP server. The next step 7. Just a second to start to load the data and to show what is the specific in development of this stage of the project. In this stage, we are working with Racking Retriever project because RAG ingester was only for loading the data and for searching the data, but RAG Retriever retrieves the data in different ways. Here, a specific is that we had a simple chat client, we had a naive RAG chat client, and here we will have a third variant of chat client. It will be agentic chat client. And that's for a while. There is an interface, there are a factory. Just a second. rough retrieval application. I have created this part of the application to use in-memory database to show the evolution of the project in the different steps of development in different versions.
Next will be the REST
Yes,
calling,
REST calling.
video production
Mm-hmm.
application,
Yes,
but through REST.
yes, true REST by using the client API, one of this project video production store client. Just a second. Now it is started. I will load the data. Racking guest in gesture. SRC mine endpoints. Reload. Thank you for being here. the last one. 2007 and 8, I was associate professor, no, associate assistant in Technical University, Sofia, and the situation was the same. When I started the programming classes, whole class, and at the end of the class, only several people, but more interesting about learning new something about programming. And now I have loaded data, and the specific here is that here we had specified domain object describing domain object of video production store. The project is evolving, and here are the domain objects. We had LLM response. I will show you after a while. The service, here we had several services. 4 services for working with these domain objects. For example, if we look at this service and we see the methods with public visibility, get video editing card list, document, and now we had persistence layer. We had here we have a persistence layer with defined interfaces repositories about every domain object. It is the interface of working with this object, and we had implementation, in-memory implementation, but in the next version of the project, version 6, we will have another implementation which will be implementation by calling here here in the repository, we will call the REST client, which will extract data from video production store by REST calling. And now we will take a look at the configuration to see what is new. A good good practice is for well-defined structured configuration and well documented. Everything is easy to be found here. Here are the new entries of this configuration parameters. About agentic rack, system prompt template. Where is the file? We will take a look at this. And agentic rack. We must take a look at how is chat client is created. Agentic rack chat client don't use advisor as the naive rack. It is without advisor and client and factory rack advisor factory. It is creating different different advisors, and here for the where are not search request advisor agentic rack. Where was I wanted to show that each by qualifier agentic chat client. I wanted to show that here is not advisor in the chat client, and the specific is that that the chat client is using tools here, and just a second. Where are the tools? Tools are here, and the tools, as I mentioned, are some provided functionalities which are described. About the tools is very important to describe what functionality this method provides, to be described in a good way of the LLM to be able to choose the right tool, to choose the right tool, and to pass the parameter if there is a parameter, and to make decision to use and execute this tool. Now, all the logic is move in these tools. These tools are separated according to LLM, how to use the what kind of business logic we had, according to the questions that can be given to our system, and for every different domain object, we have different tools. These are different available think it as an API which provides some information. It's like a service or like an API which can be called from the model, and it holds service some kind of service data. For example, here this tool, this method get customer by video card ID will use customer service. You can see that use customer service. It gives, if description gives the opportunity this tool to be called from the LLM, and after that, after calling to the LLM, here is the business logic. It will call the service. Call the service, and the service will create will do what is needed. For example, here it will call the repository. Here the repository is from in-memory database, but in the next version, according to the configuration, different beans are created with different repository, and will be called repository by which will extract data from with the help of HTTP REST client. And here the specific is that in agentic RAG there are no advisors, only tools, and the LLM make decision which tools to call. And we have tools for 4 of our domain objects, and one tool which is capable for searching and gathering information in our vector store. Vector store is additional tool, additional source of data. And the interesting here is if we execute, just a second, if we execute some searching query, retrieval, just a second, where is endpoints, agentic RAG. For example, this query, which customers have purchased the DPS velocity, and what are the technical specification of this card. The LLM make decision. We will go to the traces here. I will refresh. Добре. И аз благодаря много. Okay, the technical guys are sending me a message that the time is over. Oh, thank you, thank you guys, thank you everybody. Thank you. You can pull the code from the repository. Did you stop the recording? If you want to stop because the time is over, because we are over the limit, we can stop. If not, I can continue. If this, I can hear. Ами дайте ми някакво време, да кажем няколко минути, ако искате, колкото може да ми дадете. Моля? Добре, супер. Благодаря. Да го довърша. Да. Благодаря. Okay, I will continue. I will continue. Thank you. And now I will show the traces of this request. It was this is the last. This is the last one. Here, here you can see what is happening under the how to say it. What is happening now? My question was which customer has purchased DPS velocity and what are the technical specifications of this video card. It means that the LLM was first check if there is a video card DPS velocity, and after realizing that there is such kind of card, to check about the orders, which customer had made the orders. After that, checking the customer, and after that, with the name of DPS velocity, it will check our knowledge base if there is information about this video card. And it is what is happening in the in the traces of the flow. Chat client is called, the model is called, and the LLM is making the decision what to do. The first thing is checking video card by name. There is a created tool in the with this for this domain video card, a tool for this operation describe tool. This tool is going to repository. Here in the repository, I had put some markers that the repository is in memory repository, and after that, it is extracting the data from the video editing card. After that, the LLM have the information about video editing card, and it is making decision which tool to call according to the first query. The next tool is customer by video editing card. This tool is working with customers and video cards and orders. Join of these tables in our relational database. Next time, using the repository in memory repository. After that is finds the information for customer order and video editing card DPS velocity. And after that, the model has this information and wants to take hardware specification about this video editing card, and the tool which here the important is the description of the tool. Which which provides the searching in our vector store, and the import I will show after a while is in the system prompt. There is written if there is a need of some technical information, ask this tool. I will show it after a while. And here you can see that this operation is longer because it makes in the vector database search. It is longer than here these operations which are in the in-memory structure of relational database. And after that, the information is combined. And it is received in a good way. customers who purchased DPS velocity to customers with information about them and technical specification about this video editing card. Now interesting is to show you the prompt. Here is the system prompt. I mentioned that there are tools for everything, for gathering every kind of information. There are no advisors, there are only tools. But here in the system prompt are given the rules how to use the tools. Look there. Description of every tool what is providing. For example, knowledge base tool, detailed technical specification of video editing cards. The other tools, prices, customer details, and so on. And the instructions are very important. These instructions, where was it? The language, when question requires multiple sources, call the necessary tool sequentially and combine the result. There must be, do not repeat the search with different queries to prevent having a cycling. I had this kind of issues. If here, for example, this line is missing, the LLM is making cycling. One tool, another tool, one tool, another tool. Very specific according to the data and to the data sources. Here the settings are very important in about this, how to manage the work of the manage the work of the LLM, by which tools and how to use the tools. And something important, maybe not. What will be in the next step? In the next step, we will add another implementation of repositories, which will be repositories which will use the packaged REST client, which is video production store client, according to which use the REST to go to video production store. And here the specific in the next version, just to show the code, not to start the project, to show the code is here the persistence, second implementation, HTTP client. We had a dependency in this project, dependency of video production REST client, and have a layer here, which use this this client. And here, for example, instead of in-memory application, in-memory implementation of the database, for example, customers, if we take a look at one method, find all customers, is using our data structure, memory data structure, but find all customers with this implementation of the repository, it will be different. It will use find all. it will use our HTTP client. Our HTTP client find out, but this client is defined. This client is defined somewhere, somewhere here in the code. Service, for example, customer service. Not LLM. This client is defined in this tools. And in the last version is the last version uses MCP client. MCP client is defined in the rack retrieval application, and this client is MCP client is set to call remotely client remotely MCP server. And the MCP server application must be started. It uses internally HTTP video production store client, which is REST client of the project video production store, which must be started. And there are configuration properties. With them, we can define if the application can use must use MCP tooling from a remote MCP server, or must use local MCP tools. But the local MCP tools had inner configuration to choose which kind of repository to have: local repository or repository which use HTTP REST client from by taking data from the other project. And these 7 steps show the evolution of the 7, 6. Did I say 6? Sorry. 7. This 7th step showed the evolution of development of this agentic rack. I think that this is according to the given time. Thank you guys for the given additional time. And thank you. I think that I'm very detailed in information, and the time is. Yes. Thank you. Thank you for being here. Thank you.